Thanks, guys. So maybe I should actually introduce myself first of all. My name is Jonathan Lambert, and I'm going to take this, I think, for the next circa 2 hours. I'm sure we're probably going to have more sessions going forward. And I suppose just maybe to introduce myself, my main role here is in relation to maths development and support, undergrad through to postgrad, students, colleagues, and things like that. My background is pure maths and statistics and a bit of computer science in there. The purpose of today's session is an introductory session to SPSS. So I think I'm going to take things, pretty slowly, okay, and try to go through some important things. The first thing, let's say from a learning outcome perspective, what I'd like to achieve is, first of all, to give you an idea of a dissertation question, if that makes sense, yeah, and probably to understand your questions as well that you're trying to answer, and see whether they fit into these categories. I do have a belief that most master's level dissertation questions, they fit into one of two categories, yeah? Either they're regression-based analysis or they're tests of differences, yeah? Okay? But albeit everybody's question, I'm sure, is different, when you really look at it from a stats perspective, most people's questions are exactly the same, yeah? You might be interested in satisfaction, the difference between satisfaction levels between males and females, as an example. You might be interested in the difference between happiness levels, yeah, for 25-year-olds compared to 30-year-olds, yeah. But it basically boils down to, the type of variables that we have, and more importantly, looking at the groupings and group differences with respect to particular variables. So what I'd like to do this evening is maybe to ask a few questions first of all, and then to present what I believe is two different types of dissertations, yeah. To have a look at the survey instrument, okay. The data that came back from the survey instrument, which is typically output in Excel format, the recoding of that particular data, okay, so that we can get it into the format to get it into SPSS, and then once we get it into this is probably the hardest bit, okay, is making sure that the data is coded up correctly for SPSS. But once we get the data into SPSS, we'll run the typical gauntlet in relation to a statistical analysis, an introductory statistical analysis, where we'll do the descriptive statistics first. That's where we're trying to understand our variables, trying to understand the characteristics associated with our variables. So we'll generate the typical types of graphs. They're very good for visualizing the distributional shapes and things like that. So there'll be lots of graphs. We'll be able to look at graphs for different factors, whether for males and females, so that you can visually see whether there's differences between groups. Moving on from graphs, we'll generate probably the more important things for most questions is the measures of center and the measures of dispersion. You'll hear things like means, medians, modes, variances, standard deviations, and things like that. For us, the two important statistics that are king, typically, okay, are the mean of your variable and the standard deviation. With them two things, we can understand basically the variable, okay? So they're so important. This ain't a stats course, okay? It's an introduction to SPSS, but I'll try to give you some background in relation to what these things actually represent from a graphical perspective, so you can visualize them rather than mathematical. So we'll generate them descriptive statistics. They're the numbers, they're the summarizing of the data down into specific values. And then what we'll do is we'll move on from them. We'll probably run some straightforward hypothesis tests, okay? So that if we do observe differences between our variables at particular levels, that we can say that we're confident that them differences are actually real. And more importantly, that them differences are representative of the population that the samples have been randomly drawn from. There's that word randomization, yeah, which is something that most students just ignore, okay? But basically, all of this particular machinery, okay, does not work if there ain't randomization, okay? So you need to randomly select from your population of interest. So for example, if I'm interested in the spending behavior of NCI students, and I know I can't get access to all of NCI students, but if I'm interested in the spending behavior of NCI students, well, maybe what I'll do is I'll ask specific students, how much did you spend over the weekend? 50 euros. How much did you spend over the weekend? 30 euros. How much did you spend over the weekend? €0. Okay, there's 3, 50, 30, 0 seems to be, oh, I wonder, is that representative of the population that's been taken from? Is that representative of NCI students? The average of it, I don't know, what is it? That's 50 and 30 and 0. That gives us 80. 80 divided by 3 is? Okay, whatever that works out as, someone worked that out for me, yeah? Okay, but that'd be the average, yeah? So are we saying then that the average of the population is in around 20, 28 euros? I don't know, yeah? Or a little bit less than that. Well, we would be able to say with a certain amount of confidence that that is the case if them 3 observations had been randomly selected from the population, okay? As I said, I can't stress this, randomization is so important, yeah? Without it, all of the inferential statistics doesn't work. It'll work, okay? But you won't be able to really sell it, yeah, to the readers, yeah? Is that okay? I've only one rule. Can I have a rule? Yeah. Which is just sit back and relax, yeah? Okay, so you can just put your pens down. We're recording this. Has anybody got any objections in relation to us recording this session? That's probably shouldn't really put people on the spot like that. If you have, maybe just send an email to me and then we won't circulate it. And also, so thanks Anne. Anne is a colleague of mine from Learning and Teaching that's recording this. This is my first time to get a session recorded live. And Rachel is another colleague of mine that I asked, before I asked Anne to record this session, who is doing, I suppose, it's peer review of me. Isn't that right, Rachel? Yeah? So thanks very much. Put you on the spot. Now you're under pressure, yeah? I'm really looking forward to reading that report. Okay, is that all right? So maybe I'll start off and let me just open up some files here as an example. Just try to set the scene. We go down here, SPSS files. Before we get to SPSS, dissertation examples. I have 2 examples here. I have this file here, NAQ, negative acts questionnaire, GHQ, the general health questionnaire, job satisfaction. So actually this dissertation, which was done here by a master's student many years back, I've taken the data that they had and I've sort of messed around with it to make things work a little bit better, okay? But basically this particular student was interested in answering a particular question, and it was in relation to sexual orientation, okay, and the different categories of sexual orientation, and whether your classification of sexual orientation has any impact in relation to negative acts that are perpetrated, if they are perpetrated on you within the workplace, and how that actually impacts on your satisfaction within your particular role, if that makes sense. So it's an important example, yeah? We don't have to have a look at the sexual orientation variable and answer a question. We'll probably have a look at different variables in there. Maybe we'll concentrate on the gender variable and maybe the age variable and things like that. But it's a typical type of analysis, yeah, that we would have. I could take them variables and I could change them. Can I ask you what, put you on the spot there, can I ask you, will it be okay if I asked you what you're interested in?
I'm doing my emotional intelligence and engagement.
So emotional intelligence and engagement, and your hypothesis is that the higher the levels of emotional intelligence, the more engaged you are within your organization, within your classroom, wherever it might be, yeah? You actually fit directly into that particular example there as well, yeah? So actually, I'm running your dissertation there, yeah, okay? I just changed the variables, yeah? Yeah. And that's another disclaimer I have, is that I'm not your supervisor, yeah? And my colleagues will probably give out to me here. But what I should say to you is this, is that your supervisors do play a very, very important role in relation to the journey that you're taking, yeah? And it's important for you to manage up and manage down, manage your supervisors, if that makes sense, yeah? And make sure that you're getting bang for buck, yeah? I'd say that, yeah? If you went over and you got a coffee and they put milk in it instead of putting cream in it, €5, you would have no problem saying, hey, there's a problem with that, yeah? So master's students probably paying 6, 7, 8, 9, 10, 12,000 euros. I see masters being sold for, yeah? Yeah. You see what I'm saying? Okay, get your money's worth, yeah? Okay, the other example that I have here is one that happened, I suppose, we're actually writing a research paper on this one, okay? It's a student's research, and we're actually taking it and we're sending it off to a journal where the student did all the hard work, who will be an author on the paper as well. We're taking it a little bit further in relation to make sure that we're dotting I's and crossing T's in relation to the statistical analysis. So actually, it looked like there was something there when we looked at it. okay? And we start fixing her up and putting it into shape and sending her off to a journal, myself and another colleague, and also the student. But the question actually that's been asked here, and I won't name the companies, is whether the outsourcing of HR functions, okay, to organizations. So we've got a HR department upstairs, okay, and that's an in-house HR department. I suppose you could outsource that to another company and let them take care of the HR functions, yeah. And the question is whether outsourcing of the HR has any impact on engagement and all of them different ways you can measure engagement within the workforce. So it's another HR sort of project. If I was to ask yourself, yeah, what your dissertation is.
The uptake of factors affecting the uptake of mobile banking apps.
Oh, interesting, yeah, okay. Have you read Michael Veraccia's master's dissertation?
Yeah.
Okay, very good, yeah, okay. So Michael Veraccia, I think it was 3 years ago, yeah. He actually has a paper in conference that's being presented next month. Is it the the Irish Management, what's that? IAM, IMA or something like that, yeah? It's being presented, yeah, which is actually something quite similar, yeah? Yeah, have a look at that. IAM, isn't it, yeah? Yeah, okay, so, yeah, interesting, yeah, okay. Your regression, yes, you're falling, I think, into that regression category. If I can get around to it, yeah, we'll have a look at that, but probably later on. I'm meant to be randomly choosing people. But you sort of hear what I'm saying, yeah, is that this is a process, yeah? I haven't done that yet, and I'm just trying to motivate you, yeah? It's a process, and if you follow the process, which is this research methodologies process, yeah? You go in at the start, you follow the process, you come out at the end with the artifact, the dissertation, if that makes sense, yeah? And it's a well-defined process, yeah? You have a particular hunch at the very start in relation to the topic, the variables and so on that you want to measure. You go off, you explore the literature, you see what people have been saying about it. Are people agreeing with it? Are people disagreeing with it? You write all that up. That helps you now to understand what you're going to add new that other people haven't done. You move on, you define the methodology, where you're going to get your data from, all of that sort of carry on, how you're going to analyze your data. Actually, you define your hypotheses in there as well, these relationships that you're looking for. Then you move on from there. Oh, you define your experiment in there. You move on, you send your survey out if it's a survey, you collect all your responses, yeah? And then we're into the interesting bit, okay? Which is the generation of your results. And we'll use these tools, this SPSS, to generate the results. Then from there, it's the analysis of those results, bringing the results into context. Does your result agree or disagree with what blogs has said in that research article over here? And the important thing I think you need to take from this is that there's no right or wrong answer, yeah? This is the scientific method, yeah, okay? You've had a hunch, a hypothesis, you've went off, you've measured it, you've done your experiment, yeah? Does what you've observed, the data, which is real, that's real, you captured it, you measured it, does that support what you started off with, if that makes sense? If it supports it, brilliant. If it doesn't support it, brilliant, yeah? Because you're going to fall into one of two camps. You're going to fall maybe into the camp where you're agreeing with the vast bulk of the literature, or you're going to fall into the camp where you're disagreeing with the literature. It doesn't matter, okay? It's you need to report that particular finding, if that makes sense, yeah? Yeah. So then that's the discussion piece, if that makes sense, and then, well, the bibliography. So I'm just looking at results generation. I'm assuming everybody has got through the methodological phase, yeah? And sort of understands what they're trying to measure. And more importantly, probably how they're going to try to do that. Okay, is that right? So I'm going to go in here to this NAQ, GHQ. I'll just have a look at the questionnaire here just to give you an idea of what's going on, just to sort of set the scene. Okay, this will probably take a second. Am I okay on the peaks? Yeah? Yeah. Okay. Okay.
Jonathan, can I ask a question?
Yep.
Is it okay to run, like I want to measure outcomes of questionnaires,
So tell me what you mean by outcomes.
So mine is on dementia training. It's the correlation between emotional intelligence and dementia training for the delivery of person-centered care. So there's the before and after, the same questionnaire before the training, after the training, and then the emotional intelligence assessment. But I want to obviously do a comparison between before and after, but then I'm struggling with how I connect the assessment with the dementia questions. No.
Okay, so you've measured individuals at some point in time, okay, and you measured them on some scale,
Yeah.
and is that the dementia scale?
Yeah.
Okay, and then you've implemented some intervention, is that right?
Yeah.
Okay. They deliver the training, yeah, okay, and then you measure the participants again on the same scale that you measured them previously, yeah? Is that right?
Yeah.
Is that your experiment?
Yeah.
Okay, so you've got the classic before and after experiment, which is a paired experiment, yeah? Yeah. Yeah.
And then just connect the two then, so there's another assessment
There's another, where's the other assessment on that journey?
on the emotional intelligence.
Okay, yeah, okay. So you've got so many things going on there, yeah. And actually, this is probably important: is that research questions, yeah, don't need 50 questions, if that makes sense, yeah. But I'm not saying yours is 50 questions, yeah. But you've got a dementia measure, isn't that right?
Yeah.
Okay, that's a scale you've pulled off the shelf. That's well recognised, yeah. That's probably the gold standard, yeah. Is that okay? Yeah. So you've got a dementia, and you've measured it here at this particular moment in time for all your participants. And then you moved on here, and in the intervening period before you measured it again, okay, you put in place an intervention.
Yeah.
And the intervention was the training, is that right?
2 days training.
The training program, yeah, okay. For carers, is it? Okay, for carers, okay, yeah. Okay, so that's that piece, yeah. Okay. And you can measure that really. So what you're really asking is this, and this is these controlled experiments, yeah. This is a real experiment, yeah. Okay. You really want these repeated measures. The repeated measure experiments are really the most powerful experiments for us. Yeah? So you have one of them. Yeah? Okay? So this, if you were to analyze it with your data, it's 2 minutes, not even that, 10 seconds. If you have your data in SPSS, click the button, output comes out. It's a paired samples t-test if we conform to the prerequisite requirements of a paired samples t-test. If the p is low, the null must go. The null being that the intervention has no impact, it results in no change. The alternative for you is going to be what you're looking for, that the intervention worked, that these scores went up or these scores went down, whichever way your scale is set up. Make sense? And you can test that, yeah. So you can do that. Now you've got something else, which is the emotional
Intelligence scale, so it's a self-assessment.
Yeah.
So basically when I started doing the training itself, it became very apparent that the emotional intelligence of the employees was very high. So there's a lot of burnout that happens when you work with people with dementia, and people leave all the time.
When the emotional intelligence is high.
Well, no. Well, it's like some people stay in the industry for a very long time,
Yeah.
and some people leave.
Yeah.
So it became apparent that those who are staying are very high in emotional
Yeah.
intelligence. So I did an assessment on that too, with everybody who participated,
Yeah.
just to see is there actually a correlation between the
Yeah.
two.
And you're using that word correlation, which is an important statistical word. Yeah. Okay. It's very important. Yeah. Yeah. So if correlation means what we think, yeah, what are we correlating emotional intelligence with? Well, the only things that we've measured are the dementia before and the dementia after. But that's measurements of the participants.
Yeah.
Whereas you had, the intervention was the training of the employees.
Yeah,
Isn't that right? Yeah. And it's the emotional intelligence of the employees that you measured.
The participants are the employees.
Oh, the participants are the employees.
Yeah.
Okay, right. Okay, yeah. Right. Yeah, that makes sense. Yeah. So, is it the case then? Just exploring this, yeah. You can all throw in as our research questions, yeah, and we can talk about them. Yeah, that's no problem. And we can always get to SPSS at some other stage. Yeah. Okay. But is it then the case? Do you? And I'm just teasing this out. Yeah. Do you believe? Is it the case that you believe that there's something going on at different emotional intelligence levels?
Yeah, there's I believe there's actually
there's a moderation.
Yeah.
Okay. So that people that have low emotional intelligence, that, let's say if we took your participants and split them up into two groups, those that have low emotional intelligence, does that relationship, let's say everybody together, you found that the intervention worked, okay? It changed the scores on the dementia scale, make sense? But then you said, I wonder what's the effect of emotional intelligence. Isn't emotional intelligence something that's actually having a part to play? Is it influencing actually what's going on? Isn't that right? Well, there's many statistical techniques that we can apply to actually take that variable into consideration, yeah, okay, and to see whether it actually has a part to play outside of the main relationship. That's it's moderating or mediating are words that are used, yeah, in relation to these variables. The other thing is we could control for emotional intelligence level and then ask the question, yeah, ignoring what emotional intelligence accounts for, does the intervention have an effect above and beyond that? Does that make sense? Yeah. We can talk again about it, yeah, okay. Yeah. All right. That's your experiment, is it?
Yeah, thank you.
Yeah. Okay. And the thing that probably needs to be fleshed out a bit is just how this variable has a part to play in there. Yeah, okay, great. Yeah. Okay. Yeah. Oh, and I'm not an expert or I'm in HR or management or business or marketing or anything like that. Does that make sense? That's a sort of caveat there, yeah. I just like to deal with variables, yeah. Okay. So let's have a look at this here. So, sorry, am I out losing that? Holy heart of man. It's very slow, isn't it? Right, guys. Any other questions while I'm waiting on that to open back up again? No? No? Here we go.
So mine was looking at basically digital natives and digital immigrants in the financial sort of technology.
Okay, I'm a little bit so.
Sorry, mine is looking at digital natives and digital immigrants.
Yep.
So that's basically people born before 1980, people born not after.
Yeah. Digital natives. There you go. That's okay. And digital immigrants.
So immigrants are born before 1980.
Before
Large technology.
1980, yeah.
And natives are born after 1980 because they grew up with technology.
Yeah, after 1980. Great. And that's a grouping variable. Yeah, you basically have. And then what do you?
I'm looking at the adoption of fintech.
Financial technology. Okay. So and then you want to know if fintech, yeah, adoption. Say it again.
So basically, is there such a thing as digital natives and digital immigrants? The adoption of fintech.
In relation, so is there differences in relation to the adoption of financial technology when you look at these two groups? Yeah.
Yes, age is obviously a variable.
Yeah.
And then my own thing is that there's not, it's mainly experience and exposure.
Yeah.
So experience would be, I found a model, a theory adoption model that has both those variables.
Yeah.
So I assume it's just getting age and going.
Yeah. Well, age is what's allowing you to classify individuals as digital natives or digital immigrants. I'm assuming that this fintech adoption is a scale.
Yes.
Yeah. So it is.
Scale.
Yeah.
Agree, disagree, and there's statements.
Statements, and you bring all them statements together. This scale will have some way of actually bringing them together. So there is a scale here. Brilliant. Yeah. Okay. That's. Oh, it's sort of. It's this test over here. Yeah, is a repeated measures test. Yeah. Okay. This test here is it's non-repeated measures, yeah. But you still have two groups. The two groups over here, the before group and the after group, albeit they're the same individuals, if that makes sense, yeah. The two groups you have here is the digital natives and the digital immigrants, yeah. Okay? You're going to measure them all on this particular construct, yeah. And then the question is whether there's a difference between their scores and their scores, average scores, yeah. The independent samples t-test. It's an independent samples test of some sort. I use the word t-test, if you adhere, if you, I suppose, adhere to the prerequisite conditions associated with a t-test. Yeah. So like any of this stuff that we're going to explore, you can put your data in, you can go to the drop-down menus, you can go to analyze, you can go to compare means, you can go for an independent samples t-test, hit the button, put your data in, the variables, and it'll give you output. Yeah, okay, very quick. What's that? Oh, everything's done for you. You don't need any, all the maths is done behind the scenes, yeah, okay? Your result of your dissertation is in 2 seconds, yeah, okay? Yeah, the hardest part, and we were talking about this earlier, Rachel, isn't that right, yeah? The hardest part of the dissertation journey is actually setting your question, yeah? And actually going off and defining your experiment and collecting your data, yeah? That is the most difficult piece. The generation of the results, I accept that when you're new to it, that it's like, oh hell, what's going on here? But it's a well-defined thing. It's press the button on this, and you get the output. And then it's having to write it up, if that makes sense, is a little bit more challenging. But yet you're following into the same sort of category here of experiment. Yeah? Yeah. Now, there's a story to be told before you get straight to the result of your experiment. Yeah? And the story that you need to tell is the story about the demographic characteristics of your participants. Not just that they're digital natives and they're digital immigrants, but you might want to bring in other variables. Like you might want to talk about the gender distribution, yeah? You know? You might want to talk about age.
As well, so
yeah.
They said that women are less likely, especially women born before 1980, are less likely to take up fintech than men.
Yeah, that's a hypothesis, yeah. And you're going to test that hypothesis, yeah, exactly. And whether you have, I'm sure we've got a lens, we all view the world with a particular lens on it, and we have a belief, but we'll know whether there's evidence to support it or not to support it when we run the particular test, yeah? Okay, so, here you go. And what have I to do here? Ask me later. Okay, ask me later. Except phone a friend, yeah. Okay, there we go, brilliant. So this was the survey, this was the thing that was sent out to people, yeah, so it was captured by hand, and it was also coded up using, we have a tool, well we used to have a tool, Lime Survey, SurveyMonkey or Google Docs, yeah, it's a similar thing for capturing responses. An investigation into the nature and frequency of bullying in the workplace. Let's just move on and have a look at the questions themselves. So there was a whole section here on demographics, yeah. Now, your variables up here, your question is whether you were born before 1980 or not. Actually, you're probably going to get their age. Yeah. Tell me your age.
Well, I mean, like, were you born, are you,
yeah.
between 20?
Yeah, I know, yeah. But have you sent it out yet? No. Get their age, yeah. That's a richer variable. Then you can break them into groups. Does that make sense after? I know you want to go into them 2 groups there, but if you have them in them 2 groups, there's nothing you can do with it. Well, you can't take them out of the groups and put them into another group. Okay. Age, get their age, the actual age of them, yeah? Okay, that's going to be important. But the point is that there's going to be so many questions and you don't need all these questions, yeah, okay? It's typically a major scale along with 1 or 2 grouping variables. In this case, gender, males, females. Now don't forget, some of these things are probably out of date now because there's lots of different ways to define gender, okay, if that makes sense, yeah? So if your thing is going to capture, it doesn't have to be binary, yeah? So we have males and females. Oh, nice one. Give me your age in years. I'll then categorize you later on if I want to categorize you into a category, if that makes sense.
Is it restrictive to stick to male and female now, or is that okay to stick to male and female?
That's an ethical. I haven't got the. I can't answer that question. Yeah. Okay. Yeah. So I don't. There's lots of them types of questions that I haven't got the answer to. You'll have to ask somebody else in relation. That's a supervisor's question, I think. Yeah. Yeah. So I don't mind. I'll kick that back to the supervisor. It depends. Yeah. You know, and you know the way I can have an opinion on it. Yeah. And my opinion would be, well, the law was changed, and I think we should respect that. And if you're going to, let's not discriminate even at this particular level. Yeah, and we're meant to be scientists. Yeah, well, you know, so let's just try to capture as much as possible. But I think that's a question for you and your supervisor. Yeah, okay, but you can see what's happening here. Are you currently employed or unemployed? If implied is what's the size of the organization. What would best describe your sexual orientation? Gay, lesbian, bisexual, heterosexual. And that's sort of it, yeah? So, you know, there's lots of questions really that you could explore from here. Like the questions that you could come out, just looking at these demographic variables is there differences between males and females? Okay? Is there differences between age categories, if you want to put them into age? Have employed people, is there more negative acts perpetrated on employed people compared to unemployed? Okay? What about the size of your organization? Is the level of general health of the participants, as measured through the general health questionnaire, is that different for different organizations? Yeah? And then, well, this was the question really that they were trying to get to, which was sexual orientation, whether there was differences. Right? How do they measure negative acts? How do they measure general health? How do they measure job satisfaction? Well, they went off and they researched, they Googled, and they looked for particular research papers to find out what were the gold standard measures in relation to these particular constructs. And there's this one here, which is the NAQR, or meaning it's the revised or reduced version. Okay? Most of these questionnaires, when they're first sent out, probably have 120 questions on them. Yeah. Okay? And they're validated, and then they go through more confirmatory studies, which then reduces them down. So this is the reduced version. And the responses, for every question you answer, never, now and then, monthly, weekly, daily. Yeah? So you can see that the response has some sort of, it's increasing, isn't that right? Okay. This is more than that, this is more than that, this is more than that, and this is very often, if that makes sense, yeah? This is an ordinal scale, and more importantly, these are called Likert questions, yeah? And there's lots of questions here. In the past 6 months, have you experienced someone withholding information which affects your performance, yeah? Well, you respond never, now and then, monthly, weekly, daily. Being humiliated, or have you experienced being humiliated or ridiculed in connection with your work? Have you experienced being ordered to do work below your level of competence? Yeah? So this particular scale, which if I scroll down here, this scale has 22 items on it, okay? And them 22 items are all going to come together, and we have a technique that's going to allow us to do that in SPSS. They're all going to come together to give you a single measure on this particular scale, yeah. And there's different ways you can do it, but typically, probably the naive way to do it, which is accepted in here, is just to sum everything up, or just get the average of all the responses, if that makes sense. There's a more advanced way to do it, which I'm not going to cover here, which is using what's known as principal component analysis and things like that, yeah, to actually get the right weightings associated with all of the items and how they come through. But there's 22 items, so we'll summarize all them down into a single value. So now for everybody that fills out this survey, we have a single measure for them on negative acts. Low measures mean that they haven't really experienced negative acts in their place of work. Large numbers mean that it's happening very frequently, if that makes sense. Yeah? Moving on, you can see here that this is the general health questionnaire. Being able to, have you recently been able to concentrate on what you're doing? Better than usual, same as usual, less than usual, much less than usual. So once again, this is trying to capture your general health and well-being. Yeah? And there's there you go. There's 12 items on that. Every single one of them are going to come together to give you a single measure for your individuals. Make sense? We're not interested in the 22 items or the 12 items anymore. Throw them away. Okay? That makes sense? Yeah. We're not interested in analysing the relationships within the scales, yeah, of the items. You're interested in using the scale for a particular purpose, yeah, okay, just to get to a particular end.
What if I'm doing a test and they actually do get more than one answer? You get like, okay, this is your overall score, but this is your score in this area, this area, this area, and this area.
Yeah.
Are you then able to plug those in and say if one of those particular areas on their own actually
Yeah,
had
yeah.
an impact or not?
Yeah, so what's the example that's given here, which is most scales have sub-constructs associated with them. Like IQ will have your reading ability, it'll have your maths ability, it'll have your spatial reasoning ability, if that makes sense, yeah, okay? And them constructs together, you can actually measure your score on them constructs, yeah? That's perfectly fine, yeah?
And then if I put that into the SPSS, like it could show me if maybe not the overall score has an impact, but one of those.
Oh yeah, that's perfectly fine. Yeah. So you can actually then delve down overall on the scale, and then the defined constructs, how people are performing on them. Yeah, that's perfectly fine. What I will say is this: is that you're not allowed pull a scale off the shelf. Okay? Not that you're not allowed. You can do whatever you want. Yeah. Okay. Pull a scale off the shelf and say, oh, there's 22 questions on it. I only really want to use 10 of them. Okay. You can do it. But actually what you end up with is a different car. Does that make sense? Yeah, okay? That might not necessarily be measuring what you think it's measuring. And this is where the concept of validity, consistency, and internal reliability comes into play in relation to the scales themselves, okay? And we have ways of actually testing for one aspect of reliability, yeah, which is known as internal consistency, which is basically this. So we'll do a Cronbach alpha analysis, yeah, to make sure that our scale is consistent. All that's really testing for is that if you're scoring high on lots of questions, you should be scoring high on the other questions, because you're really saying that you agree in some way in relation to what's being measured. Yeah? We shouldn't really have scales where you're scoring high on this question and then scoring low on this, and it's so mixed, because then the scale isn't really measuring what you think it's measuring. Yeah? It could be measuring different things. But that, it might be from a subconstruct perspective, you have them different characterizations. Yeah. Okay? So what I'm really saying is this: if I feel like that there's lots of negative acts being perpetrated on me in work, well then for all of them questions that I have here, now they can be reverse coded. Okay? Try to make sure people are reading questions. But what I should be saying is I should be in agreement with most of them, with them questions. Does that make sense? And that's what we're going to measure, internal consistency. Okay?
No, I just wanted to ask if there was, so a validated scale, it's an American study, and then obviously the Irish delivery training is very different. So there is some questions that aren't covered in the training. So I was going to use the whole scale and then reference that some of these actually aren't delivered in the training, and therefore they score whatever.
Yeah.
Is that really clear?
Well, I've got one question for you, yeah? Okay?
Yeah.
So because there's two things you're talking about, yeah? You're talking about your intervention thing here, your training, yeah? And we're talking about this scale that's measuring these 2 points, yeah? Okay? There's nothing wrong with taking questions out of a scale, but all I'm saying to you is it's not my scale anymore, so don't be saying it's my scale. Does that make sense, yeah? Okay? It ain't it. You just broke it. You removed. We went through an exploratory study. We went through many confirmatory studies to make sure that the scale is measuring what it says it's measuring, yeah? It's measuring happiness, yeah? You took 3 questions out, but they're probably the main questions that really help me understand happiness. It's not measuring happiness anymore. It's measuring something, but don't define it as happiness, and don't define it as happiness the way I'm saying it's happiness. Does that make sense? But that's still okay. And master's dissertations as well is what we have, so you can do whatever you want. The most important thing is this, is that as a scientist, right, even though we're not probably doing a sciencey sort of subject, but this you're doing a quantitative dissertation, the most important thing is to communicate very clearly what you've done, okay? So if you want to remove 5 questions off that, 5 items off that, that's perfectly fine. Don't hide it away, yeah? And actually someone will figure it out pretty quickly, yeah, when they look at your complicated results that are coming out of SPSS, that little number hidden away down there that we no one looked at, yeah, and they say, Jesus, they said it was a 12-item scale. Hang on, if I take this and if I divide by the standard deviation and get that, it's 22 items I should have. So the most important thing is to be honest and to say, look, we didn't believe that this fitted in relation to our demographic, yeah? We were asking people about, I don't know, what's American type questions?
It's just more medically bound
Okay,
areas
yeah,
here
yeah,
were
yeah.
more socially then.
Yes, okay. So you're removing them, but you're removing them in here, aren't you?
I haven't removed them, I've left them in.
Yeah.
But the argument that I will be having is that they weren't part of the training, so therefore
Yeah.
they can't be part of the change. Do you
Yeah,
understand?
yeah. All you're going to be able to infer, okay? You're measuring before on dementia, you're measuring after on dementia. If there is a change, your inference is going to be, what you're going to be able to infer is that this thing here was the causation now coming into play here, if everything else is controlled for, because that's really what you're doing with the repeat measures, yeah? And whatever you used here is what you're arguing caused it, okay? Is that okay? Sorry. Jesus, flying along. Okay, so enough said on that. Job satisfaction then, there is a job satisfaction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I receive recognition for a job well done. I believe management is concerned about me. Rachel, we probably need to run this in here, do we? Yeah? Well, we probably need to run this scale in here and see how we get on with it, yeah? My wages are good. All my talents and skills are used at work. I get along with my supervisors. I feel good about my job. Yeah. It's trying to measure how happy or your satisfaction, yeah, with your employment, if that makes sense. Okay, is everybody happy enough with that? And this was all coded up, and then we went back, and I should have hit this already. Let me just open this up. And I'll just open this, and hopefully this doesn't take too long. And we took the output from SurveyMonkey or whatever the tool was that was being used. Okay? So this is what it would have looked like. I'll just show you in a second. Okay. So there's a little, it probably didn't come out exactly like this, yeah, okay? But we did a little bit of things, just putting extra information and labels in, yeah, okay? Just so that we can understand what's going on. So we have males and females, yeah, so this was a gender question, but it gave us back as labels, M-A-L-E, F-E-M-A-L-E, a label of words were coming back. The age categories, yeah, you can actually see we took the age and we put them into categories, yeah, okay. Whether you're employed or unemployed. Oh, this person didn't tell us, yeah, okay. This person here didn't tell us. So every row represents one individual set of responses. Every column represents all the responses for one particular question, if that makes sense. And that's typically the dimensional sort of structure of it, yeah. Employed. The size of the organization, people didn't tell us, yeah. Sexuality, yeah. There was probably sample size, there was probably a problem here as well, trying to infer that there's something going on at all of the levels when it comes to sexual orientation. We really need to be able to make them inferences. We really need to have representative samples from all of the groups, which is probably another question that you're probably have in your mind. What size samples should I have, yeah? It's a very complicated question, actually, to be honest with you, and you typically have to do what's known as a power analysis, yeah, to really find out what an appropriate sample size is so that you can achieve a certain degree of power, okay, if that makes sense, yeah. Well, we have a rule of thumb, okay. Depends if you're doing a regression style analysis, the usual cutoff is probably 10 observations for every variable. So if I've got 10 demographic variables, and some of them have to be broken into dummy variables, which means I could probably have 15 of them all together, I need 150 observations, yeah? Okay, so if you can get your sample size up to 150, yeah? 100, get it up as high as possible, yeah? Okay? The more observations you can get, the better, okay?
If you're doing it though, from like, you know, a particular company or something like that, so like all the sales employees in company X, like,
And there's only 5 of them.
or there's whatever, 50 of them or something like that.
Yeah.
Is there like a percentage that you would need to get for it to be?
Yeah, okay. So, So are you randomly selecting from these sales employees? Are you going to try to get them all and then randomly select from
I'm
them?
going to try and get them all and see how many people do the test.
Yeah, okay. Right. So and there's this, I mean, we have to live in this world of convenience as well, don't we? Okay, so there's convenience sampling as well. Look, from a theoretical perspective, yeah, okay, it's very hard to infer about other organizations and like let's say you're working in Google, right? And you have Google employees and you're in the sales department in Google, yeah, and you measure them. I don't think you'd be able to step outside of the Google room and say something about people that work in the distribution company in sales. Does that make sense? Unless you captured them, yeah, right? So making inferences outside of your demographic is very hard to do, okay, without having evidence from them. So you need to have as many observations as possible for the groups that you want to infer about, yeah? But it needs to be random. So collect all your observations on your sales reps and then randomly select from that, which SPSS allow you to do as well. Okay, so now you've ticked the box, I have a random sample. Random samples are important. Don't get hung up on it. Okay. Right. So, and we can move on. You can see what's happening. You can see what's happening here, isn't that right? Yeah. Now, SPSS doesn't like labels. Okay? It just deals with numbers. So what we're going to do is we're going to do a coding. Most of these applications will output an SPSS file as well for you, yeah, okay? But just to show you this is the longer way of doing it, yeah? We're going to convert all of these things into numbers. One is going to, everywhere I see male, I'm going to put in 1. Everywhere I see female, I'm going to put in 2. Actually, I'm going to probably do female first because female as a word has male in it. Okay, so don't fall into that trap where you replace male and you end up at FE1. Okay, that'll filter down if that makes sense. So, but males are going to go to 1, females are 2, or whatever coding you want to use there. Okay, if you're using a regression, it's probably best to start off as 0 and then 1. 0 then is sort of the base case, if that makes sense. So now your regression will be comparing everything to males if you've coded males as 0s. 20 to 30-year-olds are coded as 1, 30 to 40s as 2, and 40 to 50s as 3. And you can see what I'm doing right across. Is that okay? Moving across here. The scales themselves, so the negative acts scale. Question 1. Oh, PT, I don't know what's going on here, yeah? Okay. Oh, part 2, question 1, yeah? But this question was actually a whole thing, yeah? It was a grouped question, yeah? So this is the first question on it, this is the second, the third, and so on. Never is going to be 1 now, and then is going to be 2, monthly 3, and so on. And then we're going to replace all of them. And you see the argument. And voila, here's one I created earlier. So this is now what we have. Is everybody okay with that? Okay. I'm going to take all of that, numbers just, from here, right across and right down as a set of numbers, and I'm going to pull them into SPSS. Yeah? Okay. How do you get access to SPSS? Well, it's on IT. Can give you IT can give you a copy of it. Okay, you can download it off our site, and then you contact IT and they give you the license key, so you can put it onto your desktop or your laptop. We also have a virtual desktop. You can log into our servers and you can use it through the virtual desktop and things like that. So whichever way you're going to do that, you'll need to figure out do one or even both. Yeah. Okay. So I've gone onto my virtual desktop here. Let me just maybe minimize this down. Okay. Oops. Minimize that. Minimize this. The virtual desktop is basically, it's like your Windows, yeah? So when I log on to the virtual desktop, I go into application shortcuts. I'll just do that. I'm going to double click on this. And I'm going to go down here somewhere, I believe. Oh, and there you go. There's 2 types of SPSS here, applications. There's SPSS Modeler, you're not using that. And there's SPSS Statistics 25, okay? So just to follow this process, I'm going to double click on that. That opens up the application. Is everybody okay with that? Okay. So the application is going to be opened up, and it's going to look something like this. Okay. Actually, there's 2 windows that open up. there's this window here where we're going to put all of our numbers and we're going to define all of our questions, our variables, okay? And then there's another one which is an output window, okay? So you can see the output window here. Oh, it's telling us that the key is going in 11 days. Everybody's on the same. If you're taking down this off, if you take this copy of SPSS down off our servers, it will expire in 11 days. But IT will update the license and just get the license off them and then put it back in, okay? So everybody's is going to go in 11 days, yeah, but the license will be fixed. But anytime you do anything in SPSS, it's going to be output to this particular window. And you can save that window, the output file, you can save it onto your desktop or onto your USB key or wherever you want to save it. Does that make sense? Okay. But your output, your results are all going to come out here. Okay. Now, let's go back in here to Untitled, and I can go back into my Excel sheet just to show you this, and I'm going to take from question 1 all the way across here, all the way down to the end. I believe that might be it, is it? Let's see. No. There's people that didn't give us any responses to any questions. Okay. I've just copied them all there. Yeah? I'll Control C. Happy with that? I'm going back into my Untitled here. This is where their data goes. There's 2 views. There's the data view and the variable view. The data view is where we put our numbers. So I just go up to it's like it looks like Excel. It ain't Excel. It's not a spreadsheet application that you can start manipulating things and putting in formulas and things like that. Okay, it looks like it, but it ain't it. Yeah. And actually, to be honest with you, if you actually really want to do any data manipulation, go back to Excel and do an Excel. Excel has a lot more functionality for manipulating your data, putting into groups and things like that. So if I just go here to the first cell, where am I going? Oh, first cell, and I'm going to go Control D, I believe. Oh, there we go. I took all the numbers and put them in. Everybody happy with that? Okay. Now, I'm not doing this. I've got one that we've made earlier. Okay, but let me just show you from this perspective. So this is like the way it was set up. Every row is, the first row is all your responses to this survey. The second row is your responses, the third row, and so on. Yeah. Each column represents the totality of responses on a particular question. So all of the gender answers are all down here. 1, 2, 2, 2, 1, 2, 2. Male, female, 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 male, female, 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 male, and so on. Make sense? Yep. Obviously, for output, we'd like the output to come out with, nice looking labels on it, yeah? Not just numbers, yeah? Trying to keep track of these numbers. So now what we're going to do is we're going to go into the variable view window. And this is where we define all of our variables, the characteristics of the questions that we asked, okay? Now, every row here represents one of those questions that you asked earlier on, okay? So, don't be overwhelmed by this, yeah, okay? Right. The first column, the first row here is my first column in my data view window, which was the gender question, isn't that right? Yeah. So let me call it gender. I'm going to go back up here. Oops. I'm going to get rid of that, and I'm going to say gender. That's a nice descriptive name to have for that variable. Do you agree? If I go back into my data view window, you can see it's after changing that variable to gender. Okay. Now, but hang on. Values are really important. I'm going to just click on the values, and we know that we're going to reverse what we did in Excel. Okay. We took the labels in Excel and put the numbers in, okay? And we're reversing that process now, okay? You might say, well, why didn't we just take them in the first place, yeah? It's a bit more, it'll cause a lot more nightmares, yeah, if you do that, yeah? So I'm going to reverse it now. So I'm going to say, what does value, SPSS, when you see the number 1, yeah, in that column, what does it represent, yeah? Well, I'm going to say the number 1 represents males, right? And I'm going to add that. The number 2 represents females. I'm going to add that, okay? And that's that variable, okay? Its values coded up. Actually, let's get rid of the decimals. I don't want it as 1.00, okay? Just 1 means males and 2 means females, yeah? Now, if I go back into my data view, you can see here that, oh, the decimals are gone, you can see that. But what we still have is we still have the numbers. Hang on, I don't like looking at numbers. But if you have a look at this up here, that button here, it's pointing at a number and it's pointing at a letter. It's a toggle switch that allows you now to switch between the numerical representation and the label representation of your variables. Yeah. So I'm going to click on that. Aha. Now we have, and you can stay there all day long just doing that if you like. Yeah. Okay. Right. Believe me, you will find yourself doing that. Yeah. Right. Now, so the most important thing that you need to define in relation to your variable is the scale of measure associated with your variable. That's the type of meter stick that was used to measure, to make your measurements. Yeah. So if I was to ask, what's your favorite color? Green. Okay. So let's say green. Okay, there you go. What's your favorite color? Black. Black. Let's say I'm randomly selecting. What's your favorite color? Blue. So I have blue, and I can continue. But I'm randomly selecting. What's your favorite color? Red. Okay. And I'm randomly selecting. I got you again. What's your favorite color? Random selection with replacement. Yeah. What's your favorite color? Well, it can't change it. You're just being red, isn't that right? Okay. Right. So it's still red, I think. Yeah. And I can go on. I ask, what's your favorite color? Black, and I can put black in there, okay? So, like, you see these people on Grafton Street, yeah, with placard boards, yeah, stopping people and asking them question after question after question, yeah, capturing responses, yeah. There's a set of data. It's raw data. It hasn't been formatted. It hasn't been summarized in any particular way. It's just raw. Does that make sense? Keep an eye on that question. Let me ask you another question. If you could regress back to when you were doing your leaving cert or secondary school and your maths teacher, and I want you to rank your maths teacher, and the scale I'm going to give you, bad, indifferent, or good. How would you rank your maths teacher? Very good. Good, yeah? Okay, so let's say G, and randomly selecting, how would you rank your maths teacher? Okay. Oh, indifferent, okay. How would you rank your maths teacher? Good. Good, okay. How would I rank my maths teacher? Bad. That's obviously not true, okay? How would you rank your maths teacher? Bad. There we go, and there's the answer. And we could keep going, capturing more and more responses, yeah? And I'm going to ask a different question, and I'm going to randomly select, and the question this time I'm going to ask is, what's the highest temperature, or what's the most extreme temperature that you've experienced? So extreme could be high, could be low, just extreme. Temperature, yeah? High. Yeah, give us a number.
45 degrees.
45 degrees. 45 degrees what?
Celsius.
Celsius. Because if I'm in America, they talk about 45 degrees Fahrenheit. Isn't that right? They're different things, yeah? Different meanings, yeah? Water freezes at 35 degrees Fahrenheit. In America. The freeze is just it's different here. Right? So it's 45 degrees. We know we're talking about Celsius, yeah? Okay. If I was to take you, what's the most extreme temperature? 42. So I'm going to put 42 down here. And we can go on. What's the most extreme temperature that you've experienced? 40 degrees, okay. Anybody go skiing? Yeah? I'm trying to get some other numbers, yeah. What's the most extreme temperature that you've experienced? 30. Okay, I thought I was leading you there onto the thing. Yeah. Minus 12, yeah, okay, because you were off skiing somewhere, yeah. And actually, I've never gone below 0, okay, because I'm from Dublin, yeah, okay. Is everybody happy enough with that? Yeah. Right. And now let me ask you, I'll ask you one other final question, yeah. How much have you got in your bank account? Okay, so everybody, you can make up a number, yeah, it doesn't matter, yeah, so don't be intimidated by what other people say, yeah, okay? We got paid today. 15 euros, okay. So you've got 15 euros. How much have you got in your bank account? 5,000. 5,000 euros, okay. Right, 5,000 euros. And how much? 300 euros, okay. And I'm going to answer. Finance made it a boo-boo with me, and I've got 0 euros. Is that okay? Right, just to make a point, yeah. So there's 4. The scale of measure is king when it comes to your variables. It defines what you can do with them. Albeit you can do whatever you want with them, okay? But it defines the types of charts that you can produce. It defines the types of tests that you can do, because all of the tests require certain types of variables, okay? And I'm trying to give you 4 examples of 4 different types of variables. So the first question I'm going to ask myself when I have a variable is I'm going to ask myself, when I look at 2 responses, okay, different responses, green and black, and you can see I could do this many ways. I could say green and blue, green and red, green and red, green and black, black and blue, black and red, black and black. Oh, but let's use them different. But when I look at 2 different responses, is black any more important than green, or is green more important than black? This is an important question that you need to ask yourself for all your variables. Yeah? Okay? And in this case here, it's not. Now let me look at the gender variable, and our responses are males and females. Yeah? So now my question is, are males any more important than females? Or are females more important than males? Yeah? Okay. Subjective, isn't it? Okay. But really from a mathematical perspective, there's no difference. Yeah? Okay. There's no natural ordering associated with them, and the word is used as nominal. Okay. So things like that, your favorite color, the type of car that you drive, yeah, okay? You drive a Mercedes, you drive a Porsche, you drive a Toyota. Actually, Toyotas aren't any more important than Mercedes or Porsches. You might say that the Porsche is more powerful than the Mercedes, but that's a different type of measurement, if that makes sense. Yeah, the number of cylinders and all of that, its braking capacity, whatever, yeah? Okay? But that variable here is measured at the nominal level, nominal, okay? Now here's a variable where we have categories. This is categories of things, so it's categorical as well. And here's a variable where we also have categories. But this time what we can do with the categories, we can order them from least important all the way through to most important. Does that make sense? There is a natural way to actually order these things relative to each other. And we say that this thing here is measured on the ordinal scale. And they're 2 important scales in SPSS. Okay? These 2 things here, if you get a number back, you're asking yourself questions, you can get numbers back. I can ask you to rank your teacher instead of on a scale of good, indifferent, and bad, or bad, indifferent, and good, to rank them on 0 to 10. Okay. What's the difference between someone that scores a 3 and a 4 on that scale and someone that scores an 8 and a 9? Are them intervals the same? It's questionable, yeah. But anytime you get a number back, and when you can add the numbers together, that temperature and that temperature, you can add them together, you get another number, okay? You see euros and euros gives you euros. They're measured on what's known as either an interval or a ratio scale. They're actually measured on what they say in SPSS, a scaled measure. So both of them are called scaled variables. The difference between these 2 is that temperature 0, if someone responds with a 0 on this scale, does 0 really truly represent the absence of the condition that you're measuring? It doesn't. That's another way to figure out that that's a particular type of variable. When I say I have 0 money in my bank account, that means I have no money. Does that make sense? Money gone, no money there. Yeah. So, but anyway, in SPSS, it doesn't differentiate between these 2. It just puts them down as scales. I spent a bit of time on that, but it's really, really important for us. So, gender. Gender is nominal. You see the 3 types here, okay? Gender is nominal, okay? I'm actually just, see this role over here, I'm just going to change the role. Yeah. Let me just put target here for a moment. That's still good. I don't know, I'm trying to break this here for a moment. No, it didn't, okay. No, okay, ignore that. I was going to try to show you something there, but it didn't work, yeah? But now you're going to go through the process for all of them questions and you're going to change them. What I want to do is I want to actually open up something that we've created that I've done already. Just bear with me. Open a data file. What am I going to? Is it network? No. Let me just get rid of that. Sorry guys, just bear with me 1 second. Okay, here we go. Okay, right. So we've gone through the process here, okay, and we've recoded everything up. Age, employed, organisation, sexual orientation, negative acts questionnaire, item 1, question 1, all the way through to item 22. Happy with that? General health questionnaire, all of the items all the way down, they're all recoded. And they're recoded with the values that we asked, like for example, NAQ here, you can see that we have 1, 2, 3, 4, and 5 is what we put them in as, and we've now represented the labels. Is everybody happy enough with that? Okay. So if I go back here, you can see now what we have is, now we've taken it from the numbers into the labels. Yeah. SPSS still doesn't deal with the labels, it just deals with the numbers. Okay. So most people would be knocking on my door, yeah, with the problem of what I've just talked about, how to get the data in there, yeah. Right? But once the data is in, the question is ready to answer, yeah. Right? So for example, sorry, what's your name? Lee. Yeah. So okay. I think you see what I'm just doing here, yeah? Okay. Yes. I'm just changing that variable, which was the gender variable, to actually be, we actually asked whether you were digital natives or not, okay? So you want to know, and I've measured the uptake of fintech, yeah? And the uptake of fintech, I measured, it's this actual item here, yeah? So it's number 6, NAQ or item 1, yeah? Okay? And I was on a scale of, in this case, from 0 to 6. 6 meaning you use a lot of it, that makes sense? And 1 meaning you don't use much fintech, yeah? So your dissertation is, your hypothesis, yeah, is that depending on your digital nativeness, yeah, when you were born, okay, after 1980 or before 1980, okay, that we should see a different behaviour in relation to fintech adoption. Is that what you're saying? Okay, yeah, okay. Assuming all of the right conditions are met, okay, it's an independent samples t-test. What the hell is he talking about? Here's your dissertation question. Analyse, compare means, independent samples t-test. NAQR1 was measuring fintech adoption, and my digital natives is my grouping variable. The groups are defined to be 1 and 2. 1 meaning I'm a digital native, 2 meaning I'm an immigrant. I hit continue, I hit OK, and that's your dissertation done. That sounds a bit mad, yeah, but that is it there. Yeah, okay. Are you happy enough with that? Okay, good, yeah. Yeah. That's it. So when I go to a dissertation, yeah, okay, and I read it, I do read it, yeah, okay. But I get down to the results because I always like to get ahead and see how the film is ending, yeah? Does that make sense? Yeah, so I get right into the results and say, where's the p-value, where's the p-value, where's the p-value? There's the p-value. Now, there's a whole argument in relation to whether we should be p-value driven. I'll let the let's say, the theorists argue that particular point, but I'm looking for what's called a p-value. And the null, every test you do, hypothesis test, has 2 positions, has a null position and has an alternative. The alternative is the question you really want to answer. In this case, you have a hunch that there's a difference between the uptake of fintech depending on your gender. So the null position is that there's no difference. And the null positions for most of these inferential tests is that there's no difference. Your intervention didn't work. So there's no difference between the before measures and the after measures. Like there'll be subtle measurement differences, yeah? Okay? Measurement error, yeah? But theoretically, there shouldn't be any difference between before. If I scored 50 here, I should be scoring 49, 50, 51 here. Does that make sense? Yeah? Okay? If I was to give you a rhyme that if you're going to leave the building with today, the rhyme is this. If the P is low, the null must go. Okay? You happy enough with that? Lower than what? Well, lower than a special number. How confident do you want to be in relation to the decision that you're making? Okay? We usually set a confidence level, or a significance level it's called, and it's at 5% in the social sciences. So if the p-value is less than 5%, you're going with the alternative. If it's not, then there's no evidence to suggest there's a difference. If the p is low, the null must go. The null position always being that there's no difference between your groups. Okay, is that all right? So if the p is low, the null must go. So the answer to your question, in SPSS, it doesn't actually give you a p, it gives you a different, it says sig, S-I-G. And there we have 0.833, actually giving you two options, 0.833 and 0.816. It's one of these you have to interpret, okay? But that's your result. Oh, that's not less than 5%. It's not less than 0.05, okay? So I'm failing to reject the null. In your situation here, what you'd be saying is that there's insufficient evidence to suggest that there's a difference between average fintech adoption compared for digital natives compared to digital immigrants. Full stop, wrap her up, off it goes on the post. Okay? But obviously in the world that we live in, we probably should tell a little bit of a story before we get to the end of it, right? Which is so that people actually understand the variables that we have. Is that okay? You see what's going on? Like, it's literally point, click, answer comes out. The hard bit is going to be, oh, Jesus, what's going on here? But if that was your question, yeah, the story is this, yeah, okay, is that, well, what we noticed was this, was that there was two groups on your fintech adoption, even though that says, look, NAQ, all right, one, the no's and the yeses, yeah. There was 22 participants in relation to the no's. 22 of your respondents, yeah, okay, were categorized as, they said that they were no, they're not digital natives, yeah. 66 said that they were digital immigrants, yeah, okay. Bit of an imbalance here in relation to them two samples, yeah. There's more captured, obviously, here, okay. Does that influence what's going on down here? Yeah, well, I mean, a lot of the research will say it does have a part to play. And actually, let's try to have balanced experiments. Balanced meaning that we try to get the same number of participants in our groups. Does that make sense? Yeah. One solution could be is to randomly select from this group 22 people.
Quick question. So let's say you only got 100 people because the room seems empty, and then let's say I don't know, 20 women, and 80 men, and then I go, right, I want to do a balance here. So I then have to get a random 20 men. Because it's way under the 100, it's not a 50-50 split. Does that sort of discount?
Well, it all has a part to play, yeah, in relation to the number of observations, even at the group level, yeah. And I don't mean to, let's say, skirt away from your question, yeah. It's very important, yeah, that we have a representative sample from all of our levels that we measure. So for males, that we have a good measurement of males, yeah, good sample size there, and for females, we have a good sample size. The question of what the appropriate sample size is requires us to do an analysis, yeah, to actually tell us actually what the sample size should be to achieve a certain type of power in relation to what we're trying to observe, right? What I mean by that is this, yeah, is that if you look up at the Big Dipper, okay, and if you look at one of the stars in the, I'm telling a little bit of a lie here, yeah, okay, but just to make the point. Right, it's meant to be the Big Dipper. Happy with that? Yeah. And if you go into Aldi around Christmas, you can buy a nice little telescope for about €100, yeah, okay? A TASCO telescope, yeah? And you can point it up to here, okay? And you can call everybody out and say, geez, look, I'm after getting that star in there. I don't know what it's called, yeah, okay? But Ursa Major, and this particular star I'm sure has a name, yeah, okay? And actually, there's a little galaxy in around here, M something, yeah, okay? But now there's that star, and you focus on it and say, look at that, yeah, brilliant. You see the star. Yeah. Now let's do something else. If you go over to Scopes in Space, it's not there anymore, yeah, okay? You can spend $3 grand on a telescope and point it at this thing here and actually see 2 stars. Yeah. The difference between the Toyota and the Porsche is that's the word. It's more powerful. Does that make sense? Yeah. So the big telescope, radio telescope, is more powerful compared to the Tasco, €100 telescope, which basically means this, yeah, that if there is a difference really there, which we don't know, yeah, if there is really 2 stars there, the big telescope is going to find it, that difference, because it's more powerful, okay? Now, things that affect power, your ability to identify the differences between the groups. You have a hypothesis that there should be a difference between these 2 things here. The test here is saying that no, there's not. That doesn't mean there's not. That's just saying that your evidence that you've captured isn't telling us that there is. There could really be a difference there. It's just that the telescope you used was from Tesco's. Does that make sense?
Yeah.
So you want to make your experiment more powerful? If you really believe, and all the literature is saying that there's a difference between males and females, yeah, okay? That there's a difference between digital natives and digital immigrants. Yeah? You want to make your experiment more powerful so that it actually does notice the difference. Increase your sample size. Okay? Yeah. So what's the right sample size? Well, you have to do a power analysis. This is back to this thing that I talked about earlier on. But I tried to give you an idea of what power is all about. But there's a tool you can use. It's called G-Power that allows you to do a priori. Test your power. I'm using a t-test. What my sample size should be before I even go out and capture my stuff. Or after it, yeah? You can do it, say, okay, here's my sample size and here's everything else I've captured. Actually, well, how powerful was my experiment? Yeah? And it'll tell you the actual power of your experiment. So, yeah. I don't want to fall into that particular chapter of the book, yeah, that tells you 30 is a good number. Anything above 30 is good, anything below 30 is bad, yeah. Actually, it doesn't matter. You're going to capture some evidence, and your evidence is going to lead you in a particular direction, I'm sure, yeah. So don't get hung up on the sample size, but yeah, get it up. Yeah, the more the better. Okay. I just need to reverse what I just did here. There was a question here, yeah?
Can I just ask why you did a t-test on that? Is it purely because you're looking at digital natives and digital immigrants? Is it because you're looking at 2 groups?
Yeah. So there's 2 groups, okay? Yeah.
So if I'm looking at 2 groups with my additional test,
Yeah.
a t-test is sent off of
Okay. Well, it depends. And that's why, well, I'll have to do something here. This ain't your stats module, okay? So you capture your data. Oh, let's have a look at this, yeah? So there's some population. Okay, that's your population you're going to sample from. Happy with that? You're going to sample. Okay? Here you go. There's your sample, yeah? They're the males. Did you say males and females, yeah? And then here's your other sample taken from the population. There's the females. You just took a big sample and you asked them in a second question whether you're males or females, which created your groups, yeah? You measured them on a scale. What scales are you using? You haven't decided yet?
Well, I've sent out my questionnaire, but there's a lot of scales, and I'm looking at a couple of different.
Yeah. Give us one of them.
So burnout.
Burnout. Okay. Yeah. Okay. So you're measuring burnout. Is that Maslach's burnout inventory? Yeah. Okay. Right. So you're measuring burnout. So you're measuring burnout, or the degree of burnout of these employees, or nurses, or whatever it might be. Yeah. Okay. But you're measuring burnout. So this scale, then everybody has a number on the scale. Okay. And then what we're going to do is that we're going to take all the males, and we're going to take all their observations, and we're going to summarize them. Okay? Summarize. Okay? By calculating their average. Happy with that? So we have their average. Let's say that's their mean. Okay? Right? And what I'm going to do is I'm going to draw a little picture here. And here's the scale. I don't know, 0, 20, 40, 60, 80, 100, 120, and so on. The scale, I don't know what the scale goes from yet, but let's say there's a scale. And I noticed that when I took the males, that the average of the males, well, in this case here, the average is 1.86. The average of the females would be 1.92. The average of the digital natives was 1.86. The average of the non-digital natives is 1.92. Yeah? Let's say your average turns out for the males, turns out to be 65. Here you go, there's the males, they're 65. The average is a measure of central tendency. It's a measure of the center of your distribution. Yeah, happy with that? Now, you know, just to get to a point, yeah, why the t-test? That's the question, yeah. So, you know that when you captured them responses from the males, that some of them had smaller responses than the average, isn't that right? And some had greater responses, okay? So everybody is a little bit of a distance away. So on a scale of, I'll pick someone else. On a scale of 0 to 100, yeah? Let's say you have a part-time job, yeah, okay? How burned out do you feel on that scale? Sorry, how burnt out do you feel? 0 means you're not burnt out. You don't feel tired and exhausted. 100 means you're absolutely wrecked, okay? If that's the way we define burnout. Where would you put yourself? 60, okay, so you're actually here, right? But actually the average is 65. Happy with that? Okay, of the sample. So you're a little bit of a distance away. There you go, that distance. To calculate the distance between two things, you just take them away from each other mathematically, yeah? That gives me the distance. But everybody in the whole sample is a little bit of a distance away from the center. Happy with that? Now, what we're going to do, we're not just going to calculate your mean value, your center point. We're going to also say, okay, how far are individuals away from the center on average? Okay, make sense? How far do you have to travel to college a day?
2 kilometers.
2 kilometers. How far do you have to travel to college? 5 kilometers. How far do you have to travel to college? 15 kilometers. How far do you have to travel to college? Yeah, 3 kilometers. So you know in natural, there's distances. We could take all the distances together, sum them up and divide by how many there is, gives us the average distance, all right? So there's nothing to stop us here from taking everybody's distance away from here, adding them up and dividing by how many there is and calculating the average distance, all right? Now, there is a mathematical problem with doing that, yeah, okay, but let's not worry about it. But you can calculate average distances, okay? So the average distance that observations are away from their mean value is defined to be the standard deviation. Two numbers are so important for us. So now we have the standard deviation. So for every sample that we take, we have two numbers that are king. Yeah? We have the mean, where the distribution is centered, and we have the standard deviation. What does the standard deviation mean? Well, it depends. It's like the size of the dress. I'm going to use this analogy. It's the size of the dress you're wearing. You're going to a ball, it's the size of the dress. Let's use European or UK numbers, is that okay? Right? So if you're in a size E, it's quite slender. If you're in a size 10, it's a little bit broader. If you're in so on, does that make sense? The dress sizes, and now you can compare them, yeah? Okay? The length of the leg on your trousers, yeah? Are you at 30, 32, 34, 36, okay? If that makes sense. But the dress is a nice analogy because every distribution now has an average dispersion, and what we do is we put it on like that, okay? See what's going on? This is trying to capture. Most people are within that. There's a few people a little bit of a distance away here, okay? And then we do the same for the females. Yeah, we measure their mean and their standard deviation. The mean gives us the center. Let's just say it's here, okay? It's 30, okay? And they have an average dispersion between them, okay? So, the question that was being asked over here is this. Is there evidence to suggest that the averages of the two groups are different to each other? We know that the individual measures are all going to differ, isn't that right? But when we bring them together as one consolidated measure of center, the mean, is there evidence to suggest they're different? Your theory, your hypothesis might say there is, yeah? Okay. So for us to show that they're different, we need to measure the distance between those two things, those two groups. Happy with that? Now, a t-test it's the ratchet, it's the device that allows you to measure the distance between two groups. Allows you to measure the distance between their centers, their mean values. Happy with that? Okay. So if you want to test whether there's a difference between the average performance of this group compared to that group, it's a t-test. If some things are important, yeah, one thing that is sort of important is the shape of the distribution. That they're normally distributed, or that, not that they're normally distributed, that there's evidence to suggest that these have been taken from a population. See, if I took every student in the world, I could calculate their mean and their standard deviation, and I could do a diagram of them, and I could say, oh, if I took everybody, maybe it looks like this. Yeah, it's symmetrical. We want that symmetry is important, and the symmetry of the population is important when it comes to a t-test to a certain degree. When samples get bigger and bigger, and when we take more samples and more samples, we're not as reliant on it. Okay, so we need to test for normality. We test for normality. Okay, are the samples being drawn from populations that are relatively normal? If so, we're into a t-test. Okay. There's other stuff you need to test for it as well, yeah, okay? But the t-test is testing for the difference between two groups here. If we deviate from normality, what the hell do I mean by normality? What time is it? It's 7 o'clock, is it? Yeah, okay, right. Can I just, sorry, okay. Right. I'm at the steering off where I want to be, yeah? And I think I'm just going to force myself back on track here, yeah? I'll get back there, yeah? Okay. We've captured all our responses, yeah? It's all in, it's all coded up. Well, the first thing I want to do is to make sure that my scale, my 22 items that I measured, yeah, are reliable, okay? The journal we took it from said it's reliable. But it's reliable under the conditions that they produced it for, the demographic that they've reported on. Does that make sense? So we really need to test to see whether we've also got reliability. They're saying it's reliable. Let's just make sure that they're right. Does that make sense? And is it reliable in these conditions? So we need to do a reliability analysis, yeah? Which is very simple and very straightforward. We go to, I've actually got a book on this, yeah? So it's downstairs. I'll take a bit of a break and I'll bring one up for you, yeah? Which walks you through all of this, yeah? Okay. I'm going to go to Analyze, and I'm going to come down to Scale, and I'm going to choose Reliability Analysis. Okay. I'm going to click on that. I'm going to just take all of my questions that are forming my particular scale, NAQ, or the Negative Acts Questionnaire, and I'm going to put them all over here under Items. Okay. Now, there's many ways we can test for reliability. The default one that you're going to choose is the alpha model, yeah, which is the Cronbach alpha model. There's different ways to do it, split files and things like that, but you're going to just go with that. But that's it, okay? And I'm going to hit OK, and I'm going to hit OK on that, and you'll see, oh, here's our output. Happy with that? So what it's saying to us here is that case summary, the actual reliability statistics. Let's write this up. Write her up. Let's not put them tables into our dissertation, yeah, okay? You can say all this maybe with a sentence or two, yeah? Okay? Table takes up a lot of room, yeah? Okay? So, of the 124 respondents, yeah, okay? The 124 respondents were measured on this NAQ or questionnaire, okay? 72 responses were valid, yeah? Okay, with 52 responses being excluded. Okay, so 58% of the responses are actual valid responses, if that makes sense. Yeah. Okay, which means that 58% of the responses answered all of the questions. Okay, so you just write that up as a narrative. Yeah. Of the 22 items, yeah, on the scale, okay, we record a Cronbach alpha value of 0.935. Okay. Does that mean our scale is good? Does it mean it's bad? The rule of thumb in NCI is anything above 0.70 is good for us, yeah? Okay. The literature would say that you need to be up over 0.9, okay, for you actually to have a reliable scale. So in this case, this is a gold standard one. This is actually very good for us, yeah. So this is evidence to suggest that let's now move on, yeah, and we're happy that this is measuring what it seems to be saying it's measuring, yeah, from a consistency perspective, okay. That's your first result. You take it up, take it out of there, you write it up. Where does that go? That goes into your methodology section. So in your methodology, where you're talking about the scales that you used, about this 22 item inventory that measures the proportion or the magnitude of negative acts, yeah, that are perpetrated on individuals within organizations, you're going to say the literature has identified in many cases its reliability. In our case, we also have achieved a reliability of 0.935 on the Cronbach Alpha scale. Okay, that's it. Full stop. Move on. You're now reliable. Okay, and you can do all the other scales. Scale reliability. I'm just going to reset this here. Oops, there we go. Reset. And this time I'm going to go down to the General Health Questionnaire. Oh, there we go. It's important that you could have things that are reverse coded, in which case it'll come up here and you're going to have to uncode them. Let me hit OK on that. And let me hit, there you go. Right, so there you go. Of the 124 responses, 79 were valid on the on the General Health Questionnaire. Okay. Of the 12 items on that scale, we achieved a Cronbach alpha value of 0.934. That's reliable. Into the methodology section. Bob's your uncle, move on. Yeah? Okay? We're now happy with our scales. Yeah? You see what's going on? Okay. Now, there's 22 items on that scale, or there's 12 items on that scale here, and I'm not interested in all your different responses on them items. Yeah? I want to know your overall magnitude, if that makes sense, in relation to your general health. Okay? What we're going to do is we're just going to calculate, well, let's just sum them up. So your totality of your responses on the scale, you'll just sum up. Yeah? More than likely what you're going to do is you're going to go back to the journal article that the scale came from, and you're going to follow their approach in relation to how to sum up your score on the scale. And a lot of them have created scales that every item has an equal contribution to make. So summing them up is very valid. You can average them and so on, yeah? Or you can do a more advanced technique. But what we'll do is we'll just sum them up just to show how to create these composite scores, if that makes sense, an overall score on the scale, okay? Because that's all you want. So I'm going to go to, am I going to transform? Transform compute variable, okay? I'm just going to click on compute variable. My target variable means, give this variable a name. So let me call it general health, okay, composite, okay. And I'm going to say that's equal to, I'm now going over here, it's here. The new variable is going to have this name, and I'm going to say what it's equal to. Well, what it's going to be equal to is I'm going to go down, find these values. There you go. It's going to be equal to the first item, okay, plus the second item plus the third item, and so on, right? Now this scale goes from 1 to 5, yeah? So the minimum you could score on the scale when I sum them all together is 12 because there's 12 items, and the maximum you could score is 60. Does that make sense? That's an interpretation now of actually, so that scale actually, if I sum them together, ranges from 12. You answer 1 on all the questions, or you answer 5 on all the questions, yeah? Okay? So you're ranging between 12 and 60, yeah? We can do different things with that then. We can calculate the mean of it, and then we can mean center it by taking the mean away from everybody's observation, which now centers everybody on the mean, yeah? So now the average will be 0 on the scale, yeah, for everybody. Not for everybody, yet the average of everybody will be 0. So now when you're doing the analysis, now the question you can answer is, when you see numbers, the question is, well, not the question, you're saying now whether that person is scoring above the average or below the average, if that makes sense, relative to everybody else on the scale. Okay? There's lots of different things you can do. This is the naive way to do it, okay? And it's accepted. If you want to have a look at the more advanced techniques, yeah, well, look, there's lots of, maybe I'll give you some references, yeah, to find them, or follow what's in the journal, yeah, that you've taken it from, yeah. it'll be well.
You know, you're saying
Yep.
out of 60, but I suppose if you're out of
Yeah.
69, you're not answering correctly.
That's right. Yeah, I see that. Yeah. Let's. So the answer to your question is, it won't be caught here. This will just do what you're saying to do. It might not be caught. You need to realize that when you present questions to individuals, you need to make sure that they're all, well, reverse coding is so important when you're presenting the questions so that people think about the responses and don't say, oh, 10, 10, 10, 10, 9, 9, 10, you know what I'm saying? That sometimes you might have to agree with all the other responses, do a 0 or a 1 or a 2. That's what we're meaning. It won't necessarily be caught. One place where you will notice it, so let me do it, okay, is here. And a Cronbach alpha value coming through as negative, yeah, indicates that there's something crazy going on, yeah, okay? That's one rule of thumb to help you to understand, yeah? But it might not necessarily be the case, yeah? And you might actually even get a Cronbach alpha value that's good, even though you've got a reverse coded question. But usually, if I see a negative one, it's bad. And the trigger to me usually is, I've got a reverse coded question in there. I better get in and find out where it is and undo the reverse coding. Let me show you how to do that. So can I just hit OK on this? So hit OK. It's now generated a new variable, which is the sum of actually just those 3 scores, yeah, on the general health. So if I go back into SPSS data file, and I come down to the end here, you can see, oh, there's that variable there. That's being created for me, yeah? Okay. And I need to give it the appropriate thing. It's now a scaled variable. All of the other things were ordinal, the items, like hearts. See, the job now is that we're creating these scales, yeah? A richer variable, yeah? Mm-hmm. If I go back into my data view window, and I come across, should be a quicker way to do this. Okay, you can see that the first person scored 3 on the general health composite. Yeah, means they answered 1 to those 3 questions. Yeah, the next person scored a 6. I don't know what combinations of things that could be. Yeah, but you see what's going on? These are the individual scores now. It's not correct for this analysis. Yeah? I've already done these composites. Right? So there they are there. I've done job satisfaction. I've taken the 12 items on it and I've summed them up for everybody. There's their individual scores. We've done negative acts, we've summed them up. And we've done the general health and we've summed them up. Does that make sense? But the process of doing that, creating them composites, is going into transform compute variable. Allows you to compute a new variable. Sorry, what's your name? Shane. So Shane, back to your question, yeah? If I go back into transform here, okay? And what I'm going to do is I'm going to do a recode, yeah, into the same variables. This is actually what you'll be doing to reverse your coding, yeah? Okay? And let me just actually get just so that I make sure that I have this correct. I'm going to do NAQ or item 1. Okay, it goes from 1 to 5. Great. So, see, NAQ or item 1 says, yeah, that is it true that lots of things happen to you on a daily basis in work? And you said, yes, it is. Yeah. But actually, all the other questions were, is it not true that loads of things happen to you, so they're negatively presented? And in that you would have to agree with what you just responded, you'd have to answer 1. Does that make sense on that? And that's this negative coding sort of perspective. So let's just assume that NAQ or item 1 is negatively coded, and I want to reverse it. Well, we can do it in SPSS. We can go to transform. Oops. Okay, transform. I can say recode into the same variable, or if you want to go into a new variable and just keep that variable as is, you can recode into a new variable. But recode into the same variable. So I'll just click on that. And let me find the variable here is NAQ or item 1. Let's put it over here. If you have more than one recoding to do, you can put them all in and do them all in one go. Okay? I'm going to go old values to new values. There you go. And now I do it. Yeah. So I'm going to say 1 should have been a 5. Okay, there you go. Add it. 2, that should have been a 4. Okay, add it. 3 should still be a 3. Okay. I remember the first time I was doing this, yeah, just to give you things that might cause a problem, yeah, that I've done this here, and I actually stopped. I said, oh, there you go, I've got them all, yeah. But actually, I haven't got them all. I've only got 3 of them going in one direction, if that makes sense, yeah. I was saying, I've got 1, 2, 3, 4, 5, that's cool, I've got them all. You haven't. We've missed out 4 and 5, yeah. So we need to put in 4 and 5. You need to do all the values, yeah. So 4 goes to 2. We're going to add that. And we have 5 goes to 1. We're going to add that. Okay. And I'm going to hit continue. And I hit OK. And all it does just tells us the output that it's done it. It's done the recoding, yeah. Probably doesn't make any. Let's go in now. Let's revalidate that scale. Okay. Analyze scale reliability. I'm going to reset that. And I'm going to put in the NAQR. 22 items. See, that recoding might get overcrowded by them other 19 items. Does that make sense? It might not be as, you know, in your face, coming out at you as in, oh, this is a problem, yeah? Okay? So it might be overcrowded. Who knows? Let's see what the stats say. And I'm going to hit OK on it. Yeah, it did. Okay? So it's still valid, even though there's an example now of where actually recoding, I reversed that. That's wrong. Does that make sense? And I'm still coming through as valid. Yeah. So just keep an eye on it. When I says that a negative number is a good indicator, it doesn't mean if you don't get a negative number that everything is right. Yeah. It's sufficient. It's a condition, but it's not necessarily covers all conditions. Okay?
There's about like 25 questions, only about 2, I think.
Well, yeah. Okay. So yeah, you need to. Yeah. Yeah, you need to recode them. Yeah, definitely. Yeah. And let's say that we had got a situation where this was coming through as 0.5, 0.6. We've said that the cutoff point of 0.7 is a good cutoff point for us, and we're happy with that. And 0.5 and 0.6, everybody is very sad typically, yeah, when their scale doesn't come through as reliable. Yeah. Well, we can try to fix it, but that will probably mean that we remove items from the scale. Yeah. Delete items, which means we're breaking the scale, right? But it's okay if you want to report it, that, look, I didn't reach reliability, internal consistency, because of these items. So I took them off, and then I got up to reliability. But let's just also keep in mind that any inferences that we're making at the end of this, yeah, ain't got to do with Bloggs' original scale, yeah? Because he'll probably be phoning you saying, you wrote that paper and published it in Nature, yeah? You know, you didn't use my scale. And you say, well, I used 18 items of it. You say, but that's not my scale. My scale is 22 items, yeah? Okay, so the editors then are, oh, what's going on? Okay, so let's see, can we get this up, is my question, yeah? Can I increase 0.911? Hopefully it'll tell me, get rid of item 1, yeah? Yeah. So let's see. Analyze scale reliability. Let's go into the statistics and let's say, oh, what happens to the scale if items are deleted? Yeah? So SPSS is allowing you to do this. Yeah? So let's do that. So items deleted, and let's just hit continue on this, forget about everything else. Yeah? And then we get this here. Okay, don't forget it was 22 items. So what this is doing now is this is running the validation 22 times, and it keeps removing an item and looks at 19 remaining items. Removes the second item, looks at the other 19 remaining. Does that make sense? Yeah. So when we remove item 1, we achieve an increase in our reliability. That's good. That's a great scale, isn't it? Yeah. Okay. The sensitivity there in relation to, it's not anything else. Nothing else is helping us out. Yeah. Item 1 increased your reliability. Yeah. So I'm not saying that this is, let's say there's a battery of things that you could go through to really make sure that things are coded up correctly. But the best place to do it is at the very start when you're putting the data in and say, did I make sure everything's being coded correctly? Are there items on my scale that are reverse coded? Have I undone the reverse coding? I'm going to check that on my protocol. I have, brilliant. I'm going to check it again. I have, brilliant. I'm going to check it again, just make sure, because you go a bit crazy, yeah, okay? And now I'm happy that everything went in correctly, yeah? Because a lot of the errors that come through from an analysis perspective are the human errors, taking things from your data and putting it in here, you know? Really, probably what would happen is that you would do that, and I would check it, yeah? You know, we pass it around, or multiple people will do a pass over, yeah? Or we'll write an algorithm to check or something like that, yeah? We can see this has all it's corrected item total correlation. Its correlation is negative. Everything else has a positive correlation, yeah? So there's another trigger coming through for me, yeah? There's something wrong going here. It's going in the wrong direction, right? Right, but I think that's enough time spent on that, yeah? So we've got a single result so far, which is our reliability. So let me go back in to my data. Okay. So Rachel, I suppose when I get that report from you, yeah, maybe you have noted this as well, yeah, is that I probably haven't achieved what I want to achieve from an outcome perspective. Look, honestly, this is the toughest and the most, it's the place where students have most headaches, yeah, is getting the data into SPSS and getting it coded up. So actually, to be honest with you, I don't mind that. How long did I spend? An hour and a half, yeah, on that, yeah, and now the reliability test. So I'm happy enough with that. So maybe what I'll do is I'll just continue on. There's going to be this video, yeah. Maybe we'll post it up. I'll check it and see how it comes out, and then we post it up. So let me just move on. The next stage is, all right, my scales are good. Let me try to define my demographics from a graphical and numerical perspective, yeah. So it's all straightforward enough, yeah. Graphs. Here's my graphs, yeah. Now, I'm not interested in any of these items anymore. They're gone. I'm interested in the composite scores. Happy with that? So I'm going to graphs. There's a chart builder tool. You can build your graphs. Best place to go is legacy dialogues. Yeah. Okay. So for legacy compatibility, you used to just go in and you'd get this pop up. It's still there. Yeah. Okay? And here's the typical types of graphs that we're interested in. Yeah. Bar charts are the most simplest charts, and they're usually used when we have nominal variables. Okay. Because the bar chart doesn't matter which way I put males and females, yeah, on the category axis, because there's no natural order to them, yeah. So just to show you how to do this, yeah, it's point and click. So I can go to bar charts. We're just going to choose simple. You can see there's 3 options here. We can cluster them based on other variables, and we can stack them based on other variables. And also how we put the data in is important. Summaries for groups of cases. We'll go with the defaults at this stage for a moment, yeah. So it's a simple bar chart, and it's going to be summaries of groups of cases. So I'm going to hit define, and what I'm going to do is I'm just going to take, get rid of that. Sorry. Gender. Not right, that should have been gender. And if I'm not mistaken, that this was males. Okay. Change. And this here is females. Sorry. Oh. Female, there we go. Okay, so I'm going to go to graphs, bar charts, simple, define. I'm just going to take my first variable, I'm going to put it in here, the category axis, okay? Now, it's going to you're not going to be presenting a graph in your dissertation, yeah, to show how high males are compared to females. So you say how this thing works, yeah, okay? And so my gender category, that's the horizontal axis, yeah? It'll look at the categories that are associated with the levels associated with that variable, which are males and females. And the vertical axis, yeah, is going to be, the bars represent n of cases, the number of cases in each category, yeah? Which is important because it gives you a different perspective on your data. It gives you the relative, if that makes sense, not the relative. It tells you how many males there was and how many females. Where I could do percentages and say, well, there was 60% males and 40% females. That's important. but I don't know, there might have only been a sample of size 20. Does that make sense? So the 60-40 means something different for a sample of size 20 than a sample of size 1,000, yeah? Right? So there's two ways to do it. So let's look at number of cases, hit OK on that, and it's very slow. There's your bar chart. There's your bar chart. Yeah. So you can actually see that there was a lot more, overwhelming number here of females compared to males in this particular study. Yeah. Okay. They're just numbers. So I can see that there's probably about 28 males. Yeah, and there's probably about, I don't know, 83, 84, 85 females. Actually, the only thing I can really say is that there's more than 20 males. Less than 40 males, yeah, because there's no real breakdown in here. There's more than 80 females and there's less than 100 females. That's probably the best you can get out of that, yeah, because they're actual lines that you can demarcate off. Okay? From a percentage perspective, that's not really given. It's telling us that there's more females than males. Simple. Oh, there we go. And let's have a look at percentage of cases, and let's hit OK. And now we can actually see, actually there's just under 80% of this particular sample is females and just above 20% is males. That's all you can say. Don't be saying, yeah, as you can clearly see from figure 1, the bar chart, yeah, of the gender distribution in our organization, yeah, okay, that there is clearly 78.56 females, yeah, and 24.7 males. You don't get that information from that. You don't get that level of granularity. Does that make sense? The best you can do is to say, as you can see from the graph, there's more than 20% males, there's less than 80% females. That's all that tells us, yeah? Let's do this again. Let's this time get the bar charts. Let's this time, we typically see the scale of measure so important. The things that we'll typically throw in here to the category axis are nominal and ordinal variables, okay? That will work on this. You can put in a scaled variable, but the scaled variable is going to try to draw all of them lines, yeah? And it just eats up memory, yeah, and eats up processing. So let's take the age of these guys. Age is going in here. There you go. Percentages, and now we get something that looks like that. Okay? So you can see that predominantly for this particular organization, yeah, the vast majority of respondents, yeah, or the largest grouping of respondents, yeah, were under 30 years of age, yeah, okay? With the smallest grouping of respondents being 50 plus years, yeah. Okay? You've only got 3 categories there, yeah. Interesting. Just under 30 years of age represents approximately 60% of the sample, with between 30 and 50 representing between 30 and 40%, and the 50 years plus representing less than 10%. You can go in, you can double click on that axis, and you can give yourself a little bit more granularity in relation to the, let's say, what are they called? The ticks, yeah, along here, the graduation marks, yeah. So now I had 2 things. I had the gender and I had the age. I wonder how many males and females there is in these categories. Yeah? So I'd like to see, maybe it's the case, yeah, that there's actually a lot more males in this, well, there wouldn't be when you look at the amount of males, yeah, but maybe in here that there's more males in here than there is females. Does that make sense? So maybe what I want to do is I want to cluster the output on another variable, yeah. So I'm still interested in the age categories, yeah. But I'd like to have males and females here, males and females here, and so on. So I can compare now across them gender categories. So let's go into graphs, legacy dialogues bar chart. Let's go for a clustered bar chart. Let's hit define. The category variable is my age. And I want to define my clusters based on gender. There you go, make sense? And let's hit OK. And now what we've done is now we've got more. So this is like cross-tabulating, if that makes sense. So you could present this through a table, yeah, where you have male and female, and you have the 3 age categories, and it tells you how many people there is in the cells. Yeah, some people like to look at tables, others like to look at graphs. Yeah, so you're a little bit more detailed here. I think we're at the stage now where that graph is just is okay to go into the dissertation, yeah? That makes sense? The other ones, probably not, yeah? Yeah, taking up too much space, yeah, when you can just say it in a line, yeah? A line of text, of narrative, yeah? So what you can actually see here, yeah, is that, yeah, in all categories, yeah, there are more women, more females than there are males, which was to be expected, yeah? The sample size in relation to that category, there was a lot more females than males, yeah? So you'd expect to see that. But maybe this is important for you when it gets to, because you've probably read lots of papers, yeah? And the paper says that the relationship between satisfaction and these other things does exist. Does that make sense? But their demographic was a particular type of demographic. So now this is something nice to talk about. Say if you don't achieve the same result as them, okay? Your results aren't agreeing with what Blog said in that report. Jesus, what am I going to do? Yeah? Well, maybe now you have an explanation as to why they're different. Yeah? One explanation is, well, in the Blog's report, the trial was balanced with respect to males and females. Yeah? In our study, there is clearly a difference across all of our categories in relation to the gender distribution, which is very clear here. Probably balanced when it comes to the 50 plus guys, yeah? But there wasn't many of them in the study in anyway. Are we okay? And you can play this game all day long, but what you're really trying to get across is a description of your variables, yeah? A description, the descriptives, graphicals. Let's take something a little bit more interesting, yeah? Let's go to graphs. Are we okay? Yeah, okay. Let's go down to histogram, okay? And let me have a look at one of my scales. Job satisfaction, okay? My composite. This is the real one that I created earlier. I'm going to put it in here, row, okay? As my variable. And I'm just going to hit OK. And now what we get is something that looks like that, okay? Which is the real distribution of a continuous variable now. That scaled variable that we've created, yeah? Okay? So we can now see the way the satisfaction, yeah? The distribution of satisfaction scores. I keep using this word, the distribution, yeah? Okay? It's how everybody's satisfaction scores are distributed across the scale, yeah? Okay? You can see predominantly, yeah? Okay? That satisfaction scores are predominantly, yeah, between 30 and 40. That's what that's saying, isn't that right? Yeah? Write it down as a narrative, yeah? Communicate that, yeah? Okay? With significantly less number of people that are less satisfied, yeah? Okay? Okay? Compared to the people that are satisfied. What does satisfied mean? That scale goes from 10 up to 60 here, yeah? Okay? What does low satisfaction, where is the cutoff for low satisfaction? Is there one? I don't know, yeah? Okay. Are there cutoff points on this scale that represent different things, yeah? Okay. Who knows, but the literature will tell you, yeah? If whether you can find a demarcation point. Anybody above that has high satisfaction, anybody below it has relatively low. I don't know, yeah? Some scales give you cutoff points, yeah? Let's say in relation to IQ, 100 is the average, yeah? Average IQ of the population is 100. Anybody above 100 on the IQ is above average, anybody below is below average, yeah? That's job satisfaction. You could do the other ones. Let's have a look at the negative acts. Negative acts, histogram. Get rid of this, and let me go down here. Negative acts. So in relation to our 146 respondents, was there any negative acts being perpetrated? There you go. Okay. Now let's keep in mind, what does high scores mean on this scale? High scores were that it's happening every day, isn't that right? Okay. So actually, these people here are people that are providing evidence, yeah, that negative acts were happening with them in their organization. Make sense? Yep. Who are them people? Yeah, I mean, that's a valid question, isn't it? Are they males? Are they females? Yeah. Now, this question was all about sexual orientation. Okay. Are they the ones that have a sexual orientation that isn't part of the norm? Can I use the right words there? I don't know. Yeah. Okay. Are they males? Are they females? Are they the 50 plus years employees? Who knows? We could break that graph up. I could go, no, I don't like using this. I like to split the file and to generate separate graphs for our subcategories, yeah, okay? But we can do it here just so that you can see them side by side. I'm going to go to histogram, and I'm going to say, I'd like you to produce that graph, but I'd like you to produce different ones. Does that make sense? In rows, yeah? Or I can do them in columns, do for each level across like that. But the rows are better for looking at the distribution relative to each other. So I wonder what does that look like for the females and the males. So I'm going to say, oh, give us out separate graphs for the levels on gender. Let's do it. I'm just we're exploring our data here. Well, there you go. Yep. I was looking at these guys. It ain't the males. Sure it's not. The negative acts are happening with the females. But hang on, we've more females than we have males, yeah? If we bumped up this male sample, yeah, would that then balance out? Yeah, see what's happening? So this is where then balanced samples are important, yeah? Okay. It might just be the anomaly that we're seeing here, that there's not actually many males in here, might just be because, well, there was only 20 males out of 146, yeah? Say if we got about 100 males in there, would there be a difference in what we're observing, yeah? Okay. I don't know, okay? But what we're seeing here at this stage, yeah, is that there just seems to be something different happening at the high levels on the negative acts scale compared to the males and female gender distributions, yeah? Something else that's very obvious is the skewness, yeah? It seems to be, the tail is going out in this direction here of the distribution. It seems to be positively skewed, which is really telling us, when you see a positively skewed distribution, it's telling us that there's not many things in the tails, which is probably what you'd expect to happen. It should be probably, I don't know, have I read the literature on this? It should be, there shouldn't really be many examples of negative acts happening in the workplace. And if there is, we probably have a bit of a problem. What about age distributions? You can go in. What about job satisfaction? Let's go in and look at job satisfaction again. But this time, instead of gender, let's just leave it there like that, sexual orientation coming through. Okay. So there you go. Once again, sample sizes are probably a problem coming through here. Whether you're classified as gay, lesbian, bisexual, heterosexual. Yeah, see, it's just hard to really take anything from that. Does that make sense? Yeah? Sample size problems here coming through. So really, for this particular study, the supervisor should have said, great work. Go on, will you go on out and get some more observations in them categories if you can, please, yeah? Okay. Brilliant work though, yeah? You know? So, because we really need to build up the sample size. Yeah. Not many people in here. Yeah. You see what's happening, yeah? So if you really want to, if there is something going on, to be able to observe it, you need observations, yeah? You need sample evidence, yeah? Right? What about the relationship between negative acts and job satisfaction? Yeah? Is it the case that negative acts are being perpetrated on, which we have evidence there is people, yeah? Is it the case that they've got very low job satisfaction? Now, this ain't a causal analysis, okay? To do a causal analysis requires us to start controlling for things and putting people into black boxes, yeah, and making sure that the windows are all closed and the air is set at the right level for everybody when we're measuring them, yeah? Okay? So it's not a controlled, randomized trial, this ain't. Okay? If you want to get causation, yeah, we probably need repeated measures. Yeah, what's that lady's name? Debbie. Yeah, are you on your phone, Debbie? I'm only joking. I'm only messing with you. Yeah. But it's back on the other side, yeah? Okay? You probably need to make sure that you have a before and an after sort of thing that Debbie's thing. So we're not going to imply any causation, yeah? Okay? We can say there's a relationship probably, yeah, but we're not saying that one thing is causing the other. Yeah? That ain't this type of experiment. Yeah? So let's graphically have a look, and anyway, let's go to graphs, legacy dialogues, scatter dot, simple, define, and let's define the x-axis as negative acts. Oh, negative acts. Sorry. Negative acts and job satisfaction. Negative acts along here, job satisfaction along here. Okay. The explanatory variable around on this axis, yeah, the one that's being affected along this axis, yeah, the dependent variable, the independent variable. There's many different words that are used, yeah, okay, right. But the thing that you believe is influencing something else will be on our horizontal. The thing that you believe is being influenced is on our vertical, yeah, okay. So that's why I believe negative acts. The more I'm being bullied and things like that in my job, I believe that the more that's going to have an effect on my satisfaction, on my happiness, or whatever we're measuring. Yeah. Okay? So I'd really like to see some sort of negatively sloped scale. Yeah. Okay, come true. So I hit OK. Voila, there it is. Yeah. Okay. Once again, sample size, bit of a problem, but you can see the trend, yeah? Maybe you just see the dots, yeah, okay? It's going down in that direction, yeah, okay? It seems to be, I'm going to try to put relief lines on it, below it and above it, yeah, visually, when I'm looking at it, yeah? I'm trying to support it, yeah, here, and put sort of a constraint here to see what's happening. Does that make sense? So all my dots, what's the best shape around it? And I believe that I can probably put a line across here, these extreme ones, and I could probably put a line across here, and then that gives me my trend down in that direction. Does that make sense? Yeah? So that's how I'm getting that from that. We could ask SPSS to find the best trend, the best fitting line to do a regression analysis graphically and give us the results. I'm going to double click on this graph. The chart editor opens up. Get rid of this. And I'm going to ask SPSS to put a line of best fit through this data set. Okay? The best fitting line is a statistical analysis, statistical procedure going to be ran, and it's going to find the best line to go through it. That minimizes the distances that the observations are away from the line. Okay? So we'll just click on it, and that will tell us the real slope of the sample. There we go. Get rid of that. There it is there. I'm just going to there's the regression equation. Actual coming through, y is equal to 45.64 minus 0.33 times your x. Yeah? Your satisfaction in work is equal to 45.69 minus 0.33 times the amount of negative acts that are perpetrated on you. That's the relationship that's coming through mathematically. I'm just going to turn off the labels. We're not interested because we're just doing our graphs. Apply. Here we go, and let's get rid of that. And now I'm going to close that down. Okay, is everybody good with that? And there you go, there's the negative trend, yeah? An analysis of the relationship was done, analysis of the strength of, the analysis of the association between the magnitude of negative acts perpetrated on employees was undertaken against their satisfaction in their job. The results are presented in figure 2, yeah? The horizontal axis represents the magnitude of negative acts. The vertical axis represents job satisfaction. That's figure 2. Yeah? Okay. As we can clearly see from figure 2 with the line of best fit, that there seems to be a negative relationship between the amount of negative acts and job satisfaction. Full stop. What we're really saying is this, is the more negative acts that are perpetrated on you, the lower your job satisfaction. Okay? The amount of variation in job satisfaction, them scores vary. That's what we're trying to understand. We're trying to understand that job satisfaction variable. If I go back to the SPSS file, data view, oh, there we go. Job satisfaction, there's the scores. Yeah, they're varying, isn't that right? There's differences, people have different scores and there's variation in them, yeah? So for me to understand job satisfaction, I need to understand the process that's causing the variation to happen. Does that make sense? Yeah? So how much of that process do I understand? Let's say from a percentage perspective. If I understand 100% of the process that's causing the fluctuations, yeah, well then I really understand the process. Does that make sense? I understand job satisfaction. Or 0% means I don't understand it at all. Can't explain anything that's influencing it. So there's the extremes. Now, if I go back to my scale, to my graph, my output, we have a value up here, r squared linear is equal to 0.27. That's multiplied by 100, that gives us our percentage, yeah? That's called the coefficient of determination, yeah? It's the percentage of the variance in your dependent variable that you can understand through the natural variation in your independent variable. And keep in mind, you control the independent variable. That make sense? Well, you're meant to in a controlled trial, yeah? Who's going into what category, who's getting what drug, albeit randomly, yeah? Okay? There's some sort of thing going on there. You've got more control over this thing here than you do over this. That's what the argument is here, yeah? Okay? But what we're saying is this, is that job satisfaction, I understand by, if I measure your negative acts, yeah, I'll be able to understand 20% of your happiness, yeah? 27% of it. That's very good, isn't it? Yeah? Now, if I take into consideration, imagine if I can find 3 variables that each account for approximately 30%. You're up to 90% then, okay? What's an appropriate amount of variation to account for? Well, it's very subjective, okay? A moment ago, we couldn't understand job satisfaction at all. Now I can understand 27% of it. It's been people's job satisfaction. So now if I can control and put in some sort of intervention, a HR policy, yeah, in relation to negative acts, yeah, to make sure that they're not happening, yeah, or to reduce, if that makes sense, yeah, well then that should, if there is a causal relationship between negative acts and satisfaction, that should have an influence then on satisfaction. And obviously from a HR perspective, maybe not here, you're trying to increase satisfaction, yeah? Okay? But some places actually try to make employees miserable, yeah? Okay? This has all been recorded. Okay, and yeah, we're just all descriptions, yeah, of our variables, yeah, and the relationships between them. It's still descriptive. We're still just describing the characteristics. Does that make sense? We don't know just yet whether what we're observing is actually representative of the population that they were taken from. That's really where we'd like to get to. We'd like to be able to say, based off them 146 observations, yeah, that they are representative. The relationships I see here, I should see in the whole population if I had the whole population in front of me. So how do we go from that description of our variables and the description of the associations that we see in our variables as measured through our sample, how do we go from that into making an inference about the actual relationships, whether they exist in the population or not? That's where you want to go to. So you can see now what's going to happen with your situation. Any inferences that you're going to be able to make are going to have to be on that demographic, yeah, in that organization, which is perfectly fine, yeah? But you won't be able to go to an airline if you're in Google. Does that, see what's going on? Yeah. Okay. But we'll be able to make inferences about the population that this has been taken from as well. Yeah. If this was just Google. Yeah. It should be representative of Google offices around the world. That should be okay. Yeah. Google in Dublin, we measured it. All things being equal, that relationship that we're finding here should be representative. It should be Google in California as well. Yeah. Okay. So we can actually, we'll take that particular jump. Yeah. But it's hard to step outside the groups that we're looking at from an inference perspective. Numbers, some people don't like to see these things here, graphs, yeah. Some people just love the numbers, yeah. And we can represent everything just through numbers. We go into analyze, descriptive statistics. There's many different ways to look at the descriptives, yeah. Numbers meaning the measures of centre, the mean, medians, modes, the measures of dispersion, the ranges, the variance, standard deviations, the quartiles, yeah, interquartile ranges, yeah, things like that. You can do it all from a numbers perspective. Oh, sorry. Let me go back to the graphs. I wonder whether there's any unusual observations in my scales. Are there any outliers? Yeah? Did the machine break when I was doing the measurement? And I have a measurement in my data. It's huge. Yeah. When I asked everybody how much they had in their bank account, I got 315 euros, 5,000. Should that 5,000 be 50? Is that representative of the population that's been drawn from? It doesn't look like it, sure doesn't. Well, it's well out compared to the other three. Very small sample there. Yeah. So now my question is that an unusual value, that 5,000, compared to everybody else? Is it an outlier? And we can look at it graphically by using a box and whiskers plot, okay, which is a nice plot. Yeah, I like seeing these in dissertations, yeah? Go down to a box plot here, okay? Simple. And, okay, my variable I'm going to look at, this is just the way SPSS is set up here, hang on. Job satisfaction is my variable I want to do the plot for, and that's not going to let me run that. It needs a category axis. So actually I'm going to do it, I can create another variable that just has 1 in it, down everybody's measurement, yeah? And then it will do it, okay? But I need a category axis for it, so I'm just going to do it on gender, yeah? It's going to do 2 separate box plots, yeah? Okay? I could do it for the whole lot by just putting in a new variable, but let me not do that. So let me just look at gender. So I'm wondering, is there any unusual values for the males on satisfaction compared to the females, yeah? Not compared to females. And is there any unusual females that have unusual satisfaction levels compared to the rest of the females? So let's hit OK. And there you go. So this is called a 5-point summary, okay, box and whiskers plot. It basically takes, sorry. So our satisfaction scale is going from 0, let's say, up to 100, who cares? And everybody is somewhere along here, okay? Oh, there we go, right? Happy with that? Everybody has a measurement along there, okay? And what this does is this is looking at quartiles and medians, the first quartile, the second quartile, which is called the median, the third quartile, and so on, yeah? Quartiles, quarters. So it's breaking the data set up into quarters. This bar here in the box, yeah, is called the median. What we know is this, is that 50% of the observations are less than the median. So 50% of the sample on satisfaction, yeah, are less than that value there. And 50% are greater than it. Make sense? Okay, this thing here is the first quartile, which means 25% of the observations are less than that. This is the third quartile, which means 75% are less than that, which means 25% are greater than that. Okay? This case number 67, yeah? Let's have a look at that one, because that seems to be an unusual value for the males. Yeah? There's a single male compared to the rest. Here's the rest of them, yeah? Okay? This guy here has been labeled as an unusual value. SPSS uses, I'm going back to this in a second, uses a circle to indicate that it's suspect, yeah? Right. And it uses a star to indicate, yeah, check it out, definitely, yeah? Does that make sense, yeah? Okay? So it has 2 ways, depending on how far it is away from the quartiles, yeah? Okay? Let's not worry about the maths behind it, okay? But there's 2 categorizations, yeah? We're just getting a circle there, so it's suspect, yeah? Just have a look. So what's happening is this, is that all my values have been ordered. Right? Don't forget, that scale now is actually up like this. All my observations are ordered. See, this is the smallest observation, yeah? The person that had the smallest satisfaction, this is the person that had the highest satisfaction, okay? And what I'm going to do is this, is I'm going to start crossing off 1 with 1, 2 with 2, okay? I'm going to keep going in, triangulating into the center, yeah? 3 with 3, 4 with 4. Oh, and I have 2 left. So somewhere halfway between them splits my data set up into 2. Does that make sense? Which halfway between them is a value, which means that this is the median, because half the data is less than it and half is greater than it. So that's my first line on my box in the box, if that makes sense, yeah? Okay? The reason why medians are used is because Medians are not susceptible to outliers. How many brothers and sisters have you got? 4. How many brothers and sisters have you got? How many siblings? None. 0. How many? 2. How many have you got? How many have you got? How many have you got? So you can see the average is in around 3 or 3, maybe 2.5, 3. Is that right? How many brothers and sisters have you got? 4. None. 1,000. It's possible, yeah. Okay. Not for me, but I think it is possible, yeah. Okay. So the 1,000 now has the effect that when I calculate the average, don't forget I asked 1, 2, 3, 4, 5, 6, 7 people were asked the question, yeah. The average now is up around 200, 300, even though 95% of the respondents were all less than 4. Does that make sense? House prices. Average house prices are influenced by those houses that are worth 1.5, 2.5, 10, 50 million and things like that. Okay, so it influences. The effect of outliers is to pull the mean towards them. So if you have an unusually high value in your data set, the average is pulled it towards it, which increases the average, which means that the average isn't a good representation of the distribution. Whereas the median is not susceptible to the outliers because to calculate the median, you immediately cross them off. Does that make sense? Yeah? Now what we can do here is play the game again. This goes with this goes with this, gives me one in the middle. Yeah? Play the game again. This goes with this goes with this, gives me one in the middle. There's my box. Yeah? So this means that 25% of the data values are less than that, 50% are less than that, and 75% are less than that. That is now my box that I have up there. Does that make sense? Yeah? My largest value in my data set is here. There's the whisker. And my smallest value is here. There's the whisker. Now, let's say that my largest value was out here. Okay? I could put a whisker there, but more than likely that will be classified as an outlier, so I'll actually put the whisker still here, and that will be given a circle. Does that make sense? So now it's the box, and there's the whiskers. It's meant to be like a cat. Yeah, it was actually clever whoever put that name on it. Yeah, box and whiskers. Yeah, okay. So that's the box and whiskers plot. Does that make sense? You see what's going on? It's a different way of looking at the data. It's not dependent on the mean. The mean and the standard deviation are the two things that are tightly coupled together. The median and the quartiles are coupled together over here. Right? When you go into non-parametric tests, when you deviate, let's say, significantly from normality, or when sample sizes are very small, what does that mean? Right? When in non-parametrics, well then medians are what are analysed. Right? But the point of this chart here is that it's a nice way to graphically calculate whether there's outliers in your data. Okay? And there seems to be here a single male. But that might actually be the important male. I'd say it probably is the important male. It's probably that male that has the high negative acts that's actually given us. Remember that one male that was hanging out in the high negative acts box? Yeah? Right? That's probably him. So we probably actually don't want to get rid of him out of the data set. The question is when you have an outlier whether you should remove it from your analysis or not. Right? In that case, I don't think I'll be removing him because I think he's the one I really want because he's the one that I'm really investigating. Yeah, he's the one that's actually there's a clear manifestation in relation to that scale. The negative acts, he's high on it. Maybe that's the case why he's going to be left in the analysis. Is that okay? Okay. Just 1 second there. I'm going to run another one. As I said, this was pure introduction, yeah, okay, to SPSS. We haven't really done much other than being able to generate graphs and things like that. We really need to get to the stage where we're looking at the descriptives from a numerical perspective and then doing our hypothesis tests. So I think the next time we meet up, I'll ask the school to communicate to you again. Maybe in 2 weeks' time we'll meet up, and I'll just concentrate on the hypothesis side of things in relation to how to run your hypothesis tests and the different types of hypothesis tests that we have. Right? But before I end, Just bear with me here, okay? So. Okay, so I'm just going to, guys, right, every presenter always has a plug, isn't that right? Okay. There's one for everybody in the audience, okay? So I'm going to go to YouTube. Here you go. Okay, so there's, just hang on a second. I know you're dying to get out of here, but maybe just give me one moment. I'm going to go to YouTube, okay? Yeah. I'm going to go to Maths and Stats, okay? And there's my mugshot there. So, right. So, this is my plug. This is my plug. Don't take this away from me. Right. So, 584 videos. Yeah, I'm happy with that. I need to get my subscribers up. Yeah, I'll turn it off. A bit of a squeaky voice, so if you can manage to get through them, well then. So, you see that little button there now? It says subscribe. Yeah. So you subscribe there. Yeah. There's another button above it says buy me a coffee. You don't need to buy me a coffee, okay? That's for people in the States, yeah? Okay, they're gonna buy me a coffee, yeah? Okay. But coffees only cost $3, yeah? You can get $5 coffee as well, yeah? But, sorry, I want the directions to here. So it'd be great if you could subscribe. It would be great as well if you could leave comments. Comments are really important. Comments can be positive, they can be negative, it doesn't matter, yeah? Okay? If you find that the video was helpful, it'd be great if you could leave a little comment. If you find that it wasn't helpful, it'd be great if you could leave a little comment as well, okay? That makes sense. But here's the landing page. So where I think you guys need to go to is, here's the SPSS playlist here, okay? And data manipulation and coding, getting your data in there, there's 12 videos on that, okay? Doing graphs and tables, there's 13 videos on it. So actually everything I did this evening is in here and in here. And also we'll have this video as well, can go up. Testing normality and all of them sort of things are in here. Correlations and regressions are in here. Non-parametric inferential tests are in here. Validating your psychometric scales are in here. And, the parametric inferentials are in here. They're the t-tests, the ANOVAs, and all of them sort of stuff. Yeah. So there's videos actually for everything there. Right? So it'd be great if you could get in here and maybe have a look at some of them videos. And then maybe the next time we meet up, we can go. Sorry. Before you go, I probably should have given you an opportunity to ask questions. But there was lots of questions, wasn't there? Yeah. Is there any other questions before we finish? No? Right, so guys, thanks.